Hey, everybody, tonight we're debating flat Earth versus globe Earth, and we are starting right now with our flat Earth team's opening statement. Gentlemen, the floor is all yours.
Okay, thank you very much. Pleasure to be here. I'm Bev. Try thinking. I'd say I'm not necessarily a flat earther because I'm a geometrically accurate realist, and flat is a two-dimensional surface, and we know from reality that elevations are measured from a horizontal base on a vertical datum. I'm here mainly because troll-induced have brought me into this arena from just stating reality facts. And so, I mean, that's why we're here. Forced to try and prove to myself that level is horizontal, and stating that the drop of the horizon is a geometric fact. So having to prove that level is horizontal, we ended up going back to first principles, right back to the basics and the basic understanding of where we're at. We found out that it's a logical base, logic and geometry are what put me here in the first place. And so, yeah, basically it's a proof, a geometric proof in reality, using 3D Euclidean space to prove that level is horizontal, which a lot of people get freaked out about, but most people know it as a reality. So we've devised a test. I'm not going to go into the test today, but I mean, anybody's willing to come around and view it if they want to. But the principles, the basic principles are this. I'll give this on the board. We've got a water level. There is a water level here, but this is a depiction of it. So in reality, you've got your water and it levels out. This is called a horizontal. One of the globe models is the hump and the drop. You've got two different models. You have to decide if you have a globe model in your head. You've got the constant drop from the point you're at, which we call the nutsack drop, we call that. And then we've got this one, which is the hump, the raise in the center, from one side to the other. That's basically where we're going to be going, or where I'll be going. Just basic logic and the contradictions within this. I personally just deal with the reality model and what is. So I'll be staying firmly grounded in mathematics and geometry and logic. So thank you very much. I'll pass it over. Who's next?
Yeah, I can go. You hear me good? Really good. So yeah, basically, I'm right the hand, Chris. I've been in the debate for a while, and yeah, I'm not here to debate either, right? Like I did that. I know you guys might be new to the debate, and you might have been expecting, oh, gravity this, gravity that, oh, this and that. But what if you're true to finding out the truth and getting down to what is real? Which one or neither? Because I don't consider myself a flat earther, right? Like flat and ball is like Democrat or Republican, right? I'm not the politics, right? I'm not it, and that's how I see it. It's a political realm of people that are like, I'm this, you're a that, I'm right because I'm a this, and you're wrong because you're a that. And I was okay with that when because of course you argue from your side, and you're like, oh, these are the facts that I have, and they'll be like, oh, these are the facts I have. So now it's just like, how do we both agree? Like, what is going to determine whether what shape anything is, right? Like, if I have a grapefruit, right? Now, how do we know this is not a square? Well, geometrically, right? Geometrically, there's aspects physically, there's physical aspects to round objects, right? Now, again, I'm with Bev on the horizontal. Like if you got the glass of water, right? Look at the line of the water would let you know that this object is not straight. So there you go. And that we start working from there. You start working from things that are demonstratable, and then those demonstratable things, like how this water is in that line, right? We can't quite describe it with words perfectly, but that's where geometry and geometric values come in, right? Like if you have a circle, 3.141, you have the diameter will go around a certain amount of times always. That's how it works in the real world. And we just switch that real world working into a language that we can talk back and forth with and prove stuff with, right? Like if I wanted to know if this was going to roll down a hill, like because round objects will roll down a hill, right? And you can prove how the behavioral aspects of the hill is off the horizontal, right? So water will tell you if you have a horizontal. So they're just logical proofs that are based on the reality. So if your logic is not based on reality, you don't have logic. So I'll concede the rest of my time. And yeah, thanks for having us, James.
Flat Earth Rossi, the floor is all yours. Final speaker for the Flat Earth Sides opening.
Right, yeah, thanks, James. Hope you can hear me fine. Obviously, my camera's not working. Is that correct? Okay, no dramas. It's good to be here again, and I've been pretty busy, but obviously I've been a strong Flat Earth supporter for quite some time now, and the one thing that most people are always hammering on about is to show us a Flat Earth model. And this is always a huge problem for Flat Earthers because basically the model only works at full scale. And, you know, the globalists are so used to seeing tiny little models like the things you hang above your baby's crib that they can't sort of understand reality any other way. So it happens at true scale. And I think the best comparison that I can give to help people to understand how the nature of the model works is to think about a fish underneath the layer of a frozen lake. So the fish under the water, under the ice, when he looks up and sees a hotspot apparition of the sun on the ice, for him, for all intents and purposes, that's his source of light and warmth. And it sort of sends out this glowing light underwater, and it's our equivalent of daylight, for example. But then we got another fish, say a few hundred meters away. When he looks up through the ice to see the sun, he sees a completely different hotspot apparition of the sun on a completely different part of the ice. And, you know, if it's a huge lake, well, you've got hundreds of different fish all looking up at hundreds of different variations of different parts of the ice, seeing their own version of a hotspot of the sun. So now if we expand that to the flat Earth model, where we have the equivalent of a layer of ice, the firmament, some estimates say at least a good 70 miles above the surface of the Earth. So every time we look up through it towards the actual sun, now the actual sun might be 100, might be 1,000, could be 50,000. We don't know how high the real true sun actually is. But however high it is, as we look up through this lens of the firmament, that is where we will see our personal hotspot apparition of the sun. So a person 1,000 miles away looking up through the firmament to the sun sees a completely different hotspot apparition of the sun in a completely different spot. And yet everybody believes that that is the one and only true and actual sun. So that is where we have this huge problem where people of science try to measure things and try to say, well, if we triangulate it, well, we calculate it's 93 million miles away, which is completely inaccurate. Everything is where it actually appears to be. So we send up hot air or helium balloons with cameras attached to them. We can get up to about 130,000 feet is about the maximum we can get to. And that gives us a lot of information. That works out to be about 23 miles off the top of my head. The sun never appears to be all that much higher. So if it is 70 miles, well, that's a bit of an overestimate. Might only be 50 miles for all we know. Might only be 40. Might only be 30. But distance is very relative when it comes to you got nothing to focus upon or to compare it to. There's nothing else visual to be able to take an estimate from. So we just take a rough estimate and we look at what we can see. So the sun is not much higher than our 23-mile range. The Earth down below, the horizon is always at eye level, of course. We see a thin blue layer, which is, for all intents and purposes, our blue sky. So when we're on the ground looking up through the blue light, that is all we see. We think we're looking into infinity, but really we're not. We're only looking up about 10 to 15 miles maximum. That's where the blue sky limit is. And then, of course, the sun itself is merely an apparition much higher. And in between that is a huge black zone. So we have a lot to understand or to comprehend about the nature of light itself. It's not what we think it is. It is actually that blue layer is electrostimulated by the sun and causes it to glow, much like an open-air neon light bulb. And that is what gives us daylight. And it works the same even if you believe in a globe, because otherwise, in the globe model, you've got the sun 93 million miles away, but it's streaming sunlight throughout the entire universe, obviously, and yet we still get night. So how can we have night if there's only a tiny shadow of the Earth blocking all this sunlight? So obviously, light itself doesn't exist even until it actually stimulates something or reflects off of it. And our atmosphere is what gives us daylight, which is not exactly sunlight. Sunlight will give a distinct true shadow, whereas daylight just gives a gentle, warm glow. It'll light up an entire room without any direct sunlight entering it. So once we comprehend our personal view of the sun is unique to us, so there's like 8 billion different suns at any given moment, depending on the time of day, I guess. And the nature of light is also unique to each and every viewer, like crepuscular rays, for example. No two people will see the same two crepuscular rays. So I think I'm sort of trying to get ahead of myself a bit here, but if we go back to the analogy of the fish, looking up at the personal hotspot of the apparition of the sun on the ice, that is virtually how we are looking at the sun, which isn't actually the sun. The true sun is well above that. And so in the flat Earth model, as the sun goes around us, a huge circumference of about 25,000 miles, which is the same as the equator, it actually gets higher to create the seasons. As it gets higher, it appears to go in a smaller circle simply because it's further away. And that will give summer in the northern hemisphere simply because the direct sunlight through the firmament is what creates the most direct light. And most direct light causes the most heat. And then as the sun gets nearer to us, it appears to make a bigger circle. Hence, it appears to go south or outwards. And that's why we get summer on the outside, on the south side. And the diluted light coming in at an angle then isn't as strong. So therefore, the inner side gets the winter. So that's our basic model with the seasons and sunlight explained. And I'll leave it at that.
Thank you very much. So those were the openings from our Flat Earth team. And folks, we will kick it up to the top row, which is our Globe Earth team. And want to let you know, folks, we are thrilled you are here. Modern Day Debate is a neutral platform hosting debates on science, religion, and politics. And we're fully neutral. So we only host debates at this channel. And so hit that subscribe button and that notification bell as well for a lot more juicy debates coming up in the future. And so with that, Globe team, thanks so much for being here as well. The floor is all yours.
Thanks, James. Right, tonight I'm not going to bore you all like I did last time with a 10-minute PowerPoint on navigation. My opening is going to be very simple. The evidence points that the Earth is a globe. Navigation, satellites, GPS, shipping, airlines, detections of earthquakes, locations, the moon phases, and so on. My main one is navigation, without going through the PowerPoint. That is the globe. On the globe, we've got longitude lines and latitude lines. When we take a navigation chart and compare the navigation chart with the globe, the lines on this all match up to this. Therefore, this is a two-dimensional representation of this, and it works. If you were to put all the navigational charts out flat, you would get that shape. And when you fold all these corners back in, it gives you a globe, proving that this is a globe. Or we live on a star-shaped flat Earth. And that's basically my opening. Just a short one this time.
All right, well, I guess that means I am up. For those of you who don't know me, I'm Dapper Dino. I have a channel. Feel free to hop on by. And I, of course, am coming to you from the actual flat Earth, the one that is, in fact, centered on Antarctica. Because one of the curious things about the flat Earth model is that it fails increasingly as you go farther and farther away from the alleged center, being the North Pole. And so it's very curious to me that we have Southern Hemisphere flat Earthers who don't have this model, but who stick with the Northern Hemisphere centered model, which actually doesn't work at all. Because one of the earliest reasons that humans thought and eventually knew that the Earth was round is actually because of navigation, as Paul was saying, but not modern navigation necessarily, even very ancient navigation. Early sailors used things like theodolites to measure the angle between where they were, where various stars were on the horizon, and things like the northern pole star Polaris, or the equator, or not the equator, sorry, the ecliptic of the celestial sphere. But also when you get to the southern hemisphere, there's also the southern celestial pole, which rotates in the opposite direction, if you're looking at it, to the northern celestial pole. None of this actually geometrically works out in terms of angles if you're on a flat plane. You have to be on something that curves as you move over it to any significant difference. Now, the flat Earth model itself fails to account for anything with any actual predictability. The best that we get are these post hoc explanations that don't actually allow us to predict anything, especially not better than the globe Earth model. One of the most important things that science lets us do is find out what we should expect to happen in the future based on our scientific understanding. So for instance, in chemistry, if you have a good understanding of chemistry, you'll know not to mix chemicals A and B because there will be an explosion. Or you will know that if you undergo process C with these petroleum products, you'll get nylon, a very handy artificial fabric out the other end. Flat Earth has yet to be able to do this. No flat earther is out there telling me exactly when the next solar eclipse is going to be and where and why. Flat Earth can't even tell me where the planets are going to be if I look up in the sky. But the globe Earth model with the heliocentric solar system has been doing this with extreme precision for hundreds of years, and the globe Earth model with a modified geocentric was doing it with less precision, but still very high precision for thousands of years. The only way that the flat Earth can work to make predictions about what is going to happen in the heavens is if you assume that the whole firmament, if you will, itself actually rotates and part of it goes under the ground and comes back up, which is why all the ancient civilizations that believed in the flat Earth actually believed that the sun came up out of some part of the Earth, went up through the sky, and then back down underground. But of course, that problem, which would solve the problem of predictions in the sky, comes up with a problem that doesn't allow for time zones. But all you have to do is look at this panel where we have people in the UK, and Australia, and in North America to know that time zones invalidate that option. Literally, the only thing you have to do to invalidate the flat Earth is pay attention to how it looks when you're outside at night in two significantly different locations on Earth. That's it. The entire thing fails. And what flat earthers have, like I said, is a bunch of post hoc rationalizations coupled with a near total incomprehension of all of modern science and the actual model that they purport to be attacking. There is actually no understanding. This is one of the reasons why when you actually ask people who know about the scientific aspects that flat Earth tends to talk about, things like weather, astronomy, geography, even just basic math, the people who know about those things have trouble even comprehending what the flat earther is trying to get across. Because the flat Earth model, it's not even wrong. It's not coherent. It is self-contradictory. It can't predict weather patterns. It can't predict anything. So all I would like really for the flat Earth is just to do a couple things. actually explain and predict observations in the real world to at least the degree of accuracy that the standard model would allow. And then also maybe as for bonus points, explain things like spherical excess or the fact that lines of longitude continue to get closer together after crossing the equator. So if you're going from north to south, they start getting bigger and bigger, but then they get smaller and smaller again. And you don't have to be a NASA scientist or a fancy navigator to do this. All you need to do is to be able to use a astrolabe and sight the sun on various stars, be in the southern hemisphere, just be in Australia, say, we have someone here who could do it, drive 100 miles in one direction. You don't even have to trust your car's odometer. You can take your own little mile marker and see what happens to both the time of day as well as the stars. And you can check all of these things, latitude and longitude, on your own. You don't need to trust anyone. Yet flat earthers only ever seem to do it in the northern hemisphere, if they do it at all. So I don't really think I have anything else. It's just the entirety of the flat earth contradicts everything we see about reality. It fails to make any predictions, and flat earthers themselves either are unable or unwilling to do any of the experiments that could either confirm or disconfirm their ideas. That's it for me.
All righty. Well, I am Leo Filius, otherwise known as Leo Filius. Most people just call me Leo. I do have a YouTube channel. I tend to focus more on astrophysics, cosmology, and quantum mechanics, but when I got the opportunity to engage in a panel discussion, 3 versus 3 on the flat earth, I had to do it. While this might sound rather boastful, I'm going to be quite honest. I don't feel that this is going to be a debate. I feel that myself and Paul and Dapper are going to spend the next roughly hour and a half to 2 hours educating 3 people who either A, are so illiterate and so incompetent that they can't actually understand all of the evidence for the earth being a sphere, or they know that it's a sphere, they know that they're wrong, but they'd rather be a Poe and troll on the internet for attention. The thing is I could go on about all the evidence and all the reasons we know that the earth is a sphere, but instead of doing that, I would just say to anyone who thinks that the earth isn't a sphere or a spheroid, you don't have to pay attention to all the evidence that's out there. You can just do the experiments yourself. You don't have to pay attention that roughly, 1,300 years ago, Eratosthenes discovered that the earth has some form of curvature on its surface, because when he observed an obelisk in 2 different cities on the surface of the earth, he noticed that at the same time of the day, the shadow that they cast was different, indicating that at 2 points on the surface of something with curvature would give that result. He actually paid somebody, I believe, to walk out what that distance would be and utilize that distance and the difference in the shadow to calculate within, I believe it was like 15 or 20% accuracy, what the curvature of the earth was. But you can ignore that. We could ignore all of the people, all of the sailors that have been sailing this planet for thousands of years, and all of the methods they had to use to accurately navigate across the planet that involved the planet being spheroidal rather than flat. We could ignore all of that. We could ignore all of the pilots that have navigated this planet that have to utilize the same exact data that you would expect to observe if you existed on a planet that was a sphere and not some flat plane. We can ignore all of that. We can ignore time zones, which indicate that we are on a planet that orbits a star and that only 1/2 of the planet roughly is receiving sunlight at any given time. We can ignore all of this data and just go out and do the experiments yourself. Try to sail from one point on the planet to another. Try to sail from Australia to Japan. And you will notice that the only way you could accurately do it is if you assumed that you were on a sphere. Try to fly from London to New York, and you will realize that when you want to plot out your path, you're going to have to assume that you are on a sphere. You can even ignore the fact that Einstein's general theory of relativity, one of the most accurate and most predictive models that humans have ever developed, tells us that the earth is a sphere for the same reason every other planet humans have ever observed and every other star or black hole or neutron star or other subgalactic object that we have observed is a sphere or spheroidal, because of the result of hydrostatic equilibrium between gravity pushing inward equally on every point on that object's surface and the resistive force of the matter that makes up that object pushing back outward, thus resulting in a sphere or a spheroidal object. We can ignore all of that. We can ignore all of the mathematical, the observational, and the experimental data, and you can just try to live in the real world utilizing a flat earth model, and you will find that every single time you will fail, and you will fail miserably. So I don't see this as being a debate. I see this as being, you can either admit that it's not that you don't have a model, it's that any model that you could bring that would substantiate your position is going to be wrong, or you can engage in what I would consider to be dishonest and or disingenuous interlocution trying to defend an obviously wrong worldview.
Very interesting, gentlemen. We are excited to go into the open discussion portion. Want to let you know, folks, our guests are linked in the description. So if you want to hear more, you can hear more from our guests. We really appreciate them. And so they're linked in the description, whether you are listening via YouTube or Twitch. We also put the links in the Twitch panels now for our guests. And also, if you're listening to Modern Day Debate via podcast, you can find the guest links in the description box for the podcast episode. So we are really excited to jump into this open discussion portion. And so, gentlemen, we assume you'll be your regular, polite, and respectful selves. And so, thanks, gentlemen. I'm sure this will be high energy. The floor is all yours.
I think we should start with the flat earthers who didn't go most recently. So
You're saying we can have a come back then? You give
yeah, I would like you guys to go first since we just
yeah.
spoke.
Okay. Well, me personally, I've wrote down 3 bits. I think it was you, Dapper, that said about an explanation of, was it spherical excess?
The spherical excess, I said, would be a nice bonus that match the accuracy of our standard models for almost anything to do with geography or astronomy.
Okay, so
Or
can
meteorology,
I
for that
take that
matter.
spherical excess, the explanation of it?
Go ahead. I would love
Okay.
to hear an explanation.
Spherical excess, as you understand it, would be an excess to the angles of a triangle,
Correct.
i.e. a triangle having more than 180 degrees.
Yes.
Right, now, in Euclidean geometry, there is a proof in mathematics, a lot of people will know that a triangle has 180 degrees. It's the basis of trigonometry as used practically for measurements of things. So when they are measuring
just really quickly,
triangles,
everybody in the chat is saying that the stream is buffering, and it's buffering on my laptop.
Oh, yeah, I'm seeing it buffer too.
okay.
Oh.
Okay, yeah, it did come back a little bit. So
It'll definitely improve. What I found out just recently, I just found out that I can't tweak Zoom too much or it does this. So it will go back to normal in about
Awesome.
10 seconds, if not already. Sorry about that, guys.
that's good. No, it's all good. It's all good.
All right. So, sorry, Bev, what were you saying?
So the triangles, there is a mathematical proof within mathematics, geometry, stating that triangles only have 180 degrees. Now, when you are out and realistically at the top of a mountain triangulating positions, you are measuring angles, sighted angles from point to point, thus making straight-sided just an angle, like any angle, measured angle has straight sides. So triangles have 180 degrees. So I would say to you, spherical excess is a triangle with more than 180 degrees, and that is impossible because there's a proof.
It's routinely measured in
Triangles
land
only
surveying.
have- Sorry?
It's routinely measured in land surveying. So if you say it's
They measure
impossible,
triangles with more than 180 degrees in land surveying. You think that
Routinely.
actually happens?
Yes, because they report their results. So if you want to say it doesn't happen,
It
Or-
doesn't happen.
then you're gonna
There's a
have to
mathematical
explain-
proof, Dapper.
there's
You're
a
the one
mathematical
that's making the
proof.
claim, not
There's a
me.
proof for Euclidean space, but Euclidean space is not the way that surface geometry is going to be calculated on a non-flat surface.
These
And
sighted
that's the
angles,
problem.
Dapper.
Can I make just a really quick statement? Most physics, especially once you start getting into advanced classical mechanics, and certainly once you're into relativity and quantum mechanics, you're not using Euclidean spacetimes.
When you're surveying, in land surveying, yeah, you do. You use Euclidean
yes,
geometry.
in land surveying, yes,
Absolutely.
you do. Yes, you do. That's why I specified what I said. I just wanted to make that clear.
When
Well, that's what we're doing. We're citing triangles, right? As in surveying.
Right. But when large-scale land surveying is done and the results are put into tabulated tables, there is in fact actual spherical excess reported in all large-scale land surveying.
It's
Now,
impossible, dude.
That's great that it's impossible, but that's what's reported. So what you need to do now is explain why it's reported, not repeat that it's impossible, because it's happening. You can say all day that it's impossible, but if you actually look at the results of large-scale land surveys,
Triangles
they
only
report.
have 180 degrees.
Okay, so I'm just going to assume you don't have an explanation, which is great. Does anyone
I do
else?
have a proof in mathematics that triangles have 180 degrees.
You have a proof that in Euclidean space that works. We're not working on a Euclidean space, and you don't have an explanation.
Can you
for
show
the
me
actual
then?
reports
Can you
of
show me
spherical
this,
excess.
please?
Yeah, I'll tell you what. I will pull up some reports with spherical excess.
No,
and
can
then
you show me, please?
I did also want to say really quickly that you're saying that it sounds like you're saying that spherical excess is something that's mathematically impossible under traditional assumptions in a flat Euclidean space. Yes, but and I'm reading this from Wolfram Math World. There's a theorem here that's an equation that defines spherical excess.
Yeah.
It
Yeah,
is
we're talking about
theorem.
sighted triangles in surveying. You go up to the top of a mountain and you sight 2 points with a theodolite and you measure the angle. You then go to the other point and do the same, and you do that 3 times. That's triangulation. You're measuring 3 angles for a triangle. Those are sighted lines. They're straight lines. That's a triangle with 180 degrees.
Of course.
Let me say real
So
quick.
that's how I'd explain that.
Yeah, well,
Sorry,
is
that's
that
about that. It's just
if
to
you're
say that
doing
you can't measure
triangulation-
respect. Sorry,
let me just
someone's
do this real quick. So if you're using triangulation, right, the only reason it will work is if the lines are straight. Now, if you try to triangulate 3 points, right, and you do this, and you curve these 2 points in any capacity, the triangulation will not work and you will not know where you are because of how triangulation works. So when you're saying, oh, we've got spherical excess, which is impossible because if the method you're using is to make a triangle and you make a triangle, it won't have spherical excess.
Wait,
So-
hold on. When you say it's impossible, what do you mean? What kind of impossibility are you referring to exactly?
In
Okay.
reality,
Like physical impossibility, metaphysical impossibility, logical impossibility? Because I can give you literally the equation for it. So obviously it's
Yeah,
not
but equation's
impossible.
not reality. So
Wait,
you don't have reality.
hold on, really quickly. Can you tell me what an equation is?
It's not. Can you hold an equation in your hand?
That doesn't answer my
Okay, well,
question.
hold on.
Can
If
you
you're
tell
gonna-
me what an equation is?
Hold on. Reality. Now, when you say triangulation, now triangulation is
Not
not something
answering
you
my
can hold. What you can hold is physical objects that are straight. And then when you measure those physical objects, they will adhere to certain laws, right? Like an equilateral triangle, they'll all be the same size. If you make one side bigger, they don't work like that. Okay, so when you start making shapes that aren't shapes, the laws in which reality works don't apply.
You know what? You know what? 100%. You're correct. I'm not even going to try to disagree or get into things like Riemannian geometry. But yeah, 100%. You're correct. I was wrong. Thank you for correcting me. I don't want to get caught up in that discussion. I don't think it's relevant to the point.
I mean,
If I can
geometry is
try
how we
to-
tell shapes. If you don't have the geometry to tell a shape, right? So if you don't know what a straight line is and you can't establish a straight line, then you can't say that another line is curved and the thing you're on is curved. So the first thing that comes is the establishment of the proofs in which we will use to determine shape. We're not just
100%.
going to assume, we're not just going to go back and forth, flat earth, ball earth, show me why, tell me, explain. We're going to be like, look,
Well,
this
100%.
is
Yeah.
reality, and let's use the reality to determine.
Yeah. 100%. You're 100% correct. Yep. Anybody else?
Yeah, a triangle on a globe, the sum of the angles of a triangle on a sphere is 108 degrees plus f, where f is the fraction of the sphere's surface that is enclosed by the triangle. For a positive value of f, this exceeds 180 degrees. So it
Yes,
does
it
take
does.
into account that the Earth is curved.
not sighted.
Okay, so here are some cited examples. Are we ready? So in 2011, the USGS conducted some surveys of US area and observed in numerous cases.
This is the United States Geological Survey, correct?
Right.
The US, okay, just wanted to
United
make sure.
States Geological Survey, who periodically go around the United States measuring distances between various points to keep maps and geological survey, well, actually, what's in the rocks accurate for the entire United States, because it's important for lots of things in science as well as industry. So they measured actual spherical excess in this measurement in 2011, ranging from about 0.5 degree to just over 2 degrees. Why did they do that? Are they lying? What is the reason that when the USGS surveyors went around in 2011 in this report and actually went around getting spherical excess numbers that are always positive, at 0.76 degrees, 0.78, why is that?
Are you suggesting that a triangle drawn on the surface of the ground will have more than 180 degrees?
That USGS surveyors, who are identified as Elk, Taylor, Browning, and Dick,
I'm just going off mathematics.
measured that. So why is it that using high precision theodolites, which is what the USGS does for their land surveying, that are accurate to within very small fractions of an angle, why is it, if it's impossible, that it happened? You have to have an explanation.
I haven't got a clue. Like, it's geometrically impossible. I haven't got a clue how it happened.
Well, it's not geometrically impossible if the Earth is actually a globe, because that's actually a requirement of a globe.
Triangles only have 180 degrees. That's a pretty simple.
Off the top of my head, no.
Well, you do that. You do that.
I can't see the second thing you're holding up, Bev.
Well, you measured
it's cut out.
the straight sides on the inside.
But those don't form a triangle.
That's not a triangle.
No, those straight sides that you're talking about aren't forming a triangle. They're forming two.
That's how you measure the angle, though.
Okay, but that's not how you do it when you're land surveying, because you can't look through the Earth.
Yeah, exactly. That's why I said straight line of sight, straight line, triangle, not curved.
So then why is it that the USGS is reporting spherical excess?
I don't know.
If the USGS if they reported that Santa Claus was real, we could care less. Okay, so if your entire wait, come on, don't interrupt. If your entire argument is that somebody told me spherical excess, I believe the Earth is a ball, and we're sitting here with logic and demonstrations of how triangles have 180 degrees and are two-dimensional shapes, right? And when you bend them down, you move into the third dimension and are no longer using the rules in which they apply to. So all of your information will be wrong because they're based on not reality.
You guys don't understand higher order geometry, do you?
You'll also remember that when I finished my opening, I said that would be bonus points. In fact, none of my opening was really based on that. It was just something extra that I would really like, would be an explanation for spherical excess.
Well, it's just the first point I always wanted to bring up.
But again, I have yet to hear an actual explanation as to why spherical excess is always reported, other than conspiracy, which is not an explanation that can simply stand on its own. You have to demonstrate that there's
I've never reported triangles having more than 180 degrees.
I've never seen your paper reporting your work in surveying, but I would be very curious to see when you do, in fact, get a team of flat Earth surveyors out and go do some proper controls to actually go see what you guys measure.
What do you mean flat Earth surveys? I've said at the beginning, just reality, right? I just come from reality. I will use surveying techniques and methods because it is reality.
Okay, well, when you guys get together, do your surveying and write up a paper, that'll be really interesting. And I will make sure to read it. And I'm sure that there will be plenty of people who go out and reproduce the experiments and see if they get the same numbers. That'll be fascinating.
Dude.
Until then,
it'll be science is what it'll be.
Yeah, until you actually do that experiment.
Geometry.
All the measurements we have of any significant distance on the Earth include measurements of spherical excess. Now, you guys don't have an explanation. That's fine. Come back and get one.
Are these distances, are you taking a straight line in between these two distances?
They're cited, so unless there's significant atmospheric problems, which they will account for and usually not measure on those days, yes, they are within that margin of error. a straight
So-
line
Have a
from
little
one
bit of
theodolite
buffering.
to another.
Hold on, bro. Hold on.
We're gonna have a
distance.
little bit of
If I have a
buffering.
distance, like if we're talking the distance between 2 points, are you going to use anything but a straight line and the shortest distance between them to get a distance?
Wait, hold on really quickly. Can I
They're
ask
not
a question?
Well, this is a pretty
Can I
big
ask a-
point here, man. This is
Can
a
I
big
ask a
point.
question? Yeah, and that's why I want to ask a question. What kind of manifold are these 2 points defined on?
What do you mean, man? They're in 3D.
He's
space.
asking Dapper,
Okay.
Yeah,
really.
in 3D space, but what kind of manifold are we talking about?
3D space is the manifold, up, down, left,
Yeah,
right.
but what's
If you
the
have something more
structure
than
of that manifold? I do.
All right, one second.
yeah, let
because
me-
that's
what
what we
more-
use.
I just wanted to make sure that Flat Earth Rossi got a chance to speak now that we finally got him back. So go ahead, Flat Earth Rossi, the floor is all yours.
Thanks, James. I was just trying to add my 2 cents in to the actual discussion quite a bit there, because they're talking about navigation, which, as we all know, was traditionally done with compasses and the observation of Polaris, which Polaris happens to align with the North Pole star. And everything in navigation was related to Polaris because it's the only fixed star. As we notice, all the other stars revolve around it. And so these navigators, that's what the latitude line is on a map, is a circle. It's drawn with a compass and it's measured with a magnetic compass. That's how you draw a circle. So anybody trying to draw a circle based on navigation, they're using a compass. That's what the east-west line is. It's a circle. But if you're then trying to do a triangle, then how are you going to measure a straight line in any distance apart from exactly north-south? North-south is the only straight lines you'll get using a compass, using any form of navigation that they've known traditionally. So anytime they try and make a triangle, the only way they're going to know a straight line is by going in a big curve. So when you make a triangle from 3 distinct points using one straight line and 2 curved ones, well, the angles won't add up to 180 degrees. That's all I'm trying to say right from the beginning. Thanks for your time.
Yeah, but we're agreeing that what add up to 180 degrees because of the curvature.
And other
Didn't
than
you say
the
it's
equator,
Yes, though?
other than the equator, no line of latitude is something you can follow without turning.
This was the point I was trying to bring up with right the hand, is that you can have 2 points on a manifold, but the minute there's curvature in that manifold, you no longer use a line to define the shortest path between those 2 points. You use what's called a geodesic. And these are used all the time in Riemannian geometry, where a triangle can certainly have 3 angles to add up to more than 180 degrees.
Wouldn't the straight line go through the ball?
No.
Okay,
Yes,
so
it
if you
would.
had a ball. Okay, hold on. I got a ball here. Now, I could build a bridge over it, right? Now that bridge would be curved, right?
Yeah,
And I
that
can
would.
drill a tunnel through it. That'd be a straight line, right?
Yes, it would.
Okay, so when you say a straight line on a sphere is following the surface of the sphere, you're wrong. The straight line would be like the radius or the diameter, right?
That's not what I said.
Okay, so you can't have a straight line on the surface of a sphere. That was my point.
Okay, so
Wait, hold on.
Cool.
What? You can't have a straight line
If you
on
had
the
a straight
surface.
line, wouldn't it go off the sphere?
If the line were tangent, yes. Yes, it would.
No, if it was curved and not straight.
If the line was curved,
Well, wouldn't it have to curve to follow the ball?
to follow the surface geometry, yes.
Okay, so then it's not straight.
Depends on the geometry.
So what I'm getting here is that I think we have a group that doesn't actually understand topology in the mathematical sense, but maybe I'm wrong. So I'd like to find out. So,
Can I get the basic facts then? Just a quick one.
Well, I want to find out if we know enough about topology for.
We want
for
to
this
do the
conversation.
basics. I want to make sure we have a
this is very
direct
basic.
understanding of the very basics of an
I've been
angle.
talking about the basics, and I don't think anybody's been following me.
An
So
angle. Can we get an angle is between 2 straight lines?
What the angle is between 2
Yes,
straight.
an angle is the measurement in between 2 straight lines.
Well, wait, what? Can you say that one more time, please? I'm sorry.
angle is the inclination between two straight lines. Imagine a circle.
No, I mean, I know what an angle
divide
is.
it into
Your definition
360,
just
and
confused me.
each one of the angles would be a division between two radius lines.
Wait, are you talking
That's what
about
an angle is, right?
Wait, you're talking about radians.
I'm talking about an angle,
Yeah, like radians.
like two
Measured
straight
like-
lines.
Never mind. I guess I'm out of my depth. I don't know what.
No, we're talking about the angle, dude, not the circumference, right? Yeah.
Maybe we can address another part that
Well,
Dapper
Phyllis.
Dino brought up about navigation,
Yeah.
because he's saying that they've been navigating for thousands of years using what they call planetary geometry, whereas that doesn't work that way at all. As I said, if you're drawing latitude lines in ever increasing circles around a center point, the North Pole, then that's why they keep on expanding. But this is why when they say they get to the equator, things go pear-shaped, because they no longer match their expectations. And the reason for that is because they've lost their focal point, which is Polaris. The Polaris was always their
what?
focal
When you say
Polaris was always the focal
when you
point for
say
navigation.
pear-shaped, what do you mean?
Yeah.
Well,
That's what I'm trying to
because as soon as you get so far away from Polaris, like anything else, it disappears due to distance and perspective. Is it the further you get away from something, the lower it gets. It doesn't mean you're going over a curve. It just means that visually it appears to get lower and lower, which is how the sun sets. It's getting further away. So you're getting further away from Polaris till you reach the equator, which is the point they've drawn on their charts, a big circle around the North Pole, which is where Polaris disappears from view. So that's why measurements get pear-shaped, because they've lost their point of reference. They have to start using something else. And as a result of Polaris disappearing, that is when they believe they disappeared over a curve. This is ancient superstitious people thinking that convergence of perspective means curvature because it's gone below the horizon. It hasn't gone below, it's just disappeared into it.
So Ross, why don't you use navigation tools from antiquity, which are available? You can simply get them. Learn how
I'm
to use
Australian
them.
and I can't see Polaris, and I'm not into ocean
You
navigation.
can see the
can't-
southern celestial pole,
Why
but that is a
can't
good
you see
question.
Polaris?
There is no southern celestial pole.
Why can you not
Well,
see
then-
Polaris?
Yeah, what? Those are both good
As I
questions.
explained to you, once you get a certain distance away from anything, even if it's a pole star, it's going to disappear from view.
That's not necessarily true. That is
All
not
buildings do
necessarily
the same
true.
thing. The stars do the same thing.
No, they
Everything
don't.
obeys laws of perspective. Of course
No,
they do.
What are the laws?
They do
hold on.
obey the law of
What are
perspective.
hold on? What are the laws of perspective?
The laws of perspective means if you get further away from something, it appears to get lower if it's really high up above you. Otherwise,
No, that's a description. What's the law?
The law? Well, it's all a visual law, isn't it?
No. Like,
Everything-
for instance, if I gave a
Everything-
law of motion, I might say force equals mass times acceleration, and then I could measure each of those with units. What is the
But we're
actual
talking
law
we're talking about a visual
of
thing,
perspective?
not a physical measurement of a force. We're talking just about a
Well, then it's
visual
not a
demonstration
law.
Yeah.
of our lips of being able to see.
We're
Of course
talking
it
about
is a law.
science here. In science, laws are equations. If you don't have an equation, you don't have a law.
No, equations are just wizardry. We don't need wizardry.
Wait,
to
hold on.
understand
What do you mean equations are wizardry? Wait, no, hold on. Okay, really quickly. Can I ask you a question? Just a very, very simple question.
That is a question.
Hold on. Is 2 + 2 = 4 a true statement or not?
2 + 2 what?
Does 2 + 2
2
equal
apples
4?
plus 2 oranges, does that equal 4 apples?
Does
No, it
2
doesn't.
plus 2 equal 4?
You're talking abstract
Why are
stuff
you
when
not answering the question?
Because 2 + 2 what?
Why does
Because
that matter?
you're confusing him with your sorcerer's ways.
No, you're talking abstract stuff of
Wait, do you
non-reality.
think that you think math is not abstract?
I'm saying it is abstract.
Yeah,
because,
it's very
if you
abstract,
say you've
of
got
course.
2
That doesn't
apples
mean it
plus 2
doesn't
apples,
work.
You've got 4 apples. If you've got 2 lemons plus 2 oranges, you don't have 4 apples.
Yeah, but you still have 4, right? You still have 4
4
objects.
things.
Yeah, you still have 4
Yeah.
objects. So 2
That's
things plus 2 things will give you 4 things, right?
Correct.
Okay, so
You
2 + 2
actually,
equals 4.
You could just say you don't have 4 things. You have one individual unit, one individual unit, one individual unit, and one individual unit. Now,
Which
Well, I'm
is
glad
4
that we've
things.
changed 2 + 2 to 1 + 1 + 1
Well,
+
'cause you're
1, but it
two-
still ends up equaling 4.
No. Hold on. When you're saying math, right? Now, when you say one is a description of like A would be in algebra, A would be a unique thing. Okay, one would if you're describing a unique
Coefficient.
thing, right, and describing another unique thing, and add them together and don't get a new thing, you can't label it a new thing. So when you say 1 + 1 = 2, one pile of sand and one pile of sand equals one pile of sand. So you're just talking in abstract number theory. You're not proving anything of the world. But if this makes you feel better, then go for it. We're trying to establish the shape of the earth.
Can I
try to conceptually describe how many grapefruits I have on my table?
Can I ask you a quick question? Do you know what mathematical logic is?
Do you know what is the definition of mathematics? What is that?
That's not what I asked you. Do you know what
how am I
mathematical?
supposed to know what the logic of what? You said mathematical logic. That means the logic of what?
I asked you what mathematical logic is, and you're asking, the logic of what? I don't.
Well, you're saying logic. Logic doesn't need something behind it, unless it's illogical. So you have logic and you have illogical. So when you
so wait, logic doesn't require axioms.
Logic doesn't need. What are you going to say? You have Shakespearean logic.
Right.
No, there's logic.
Right the hand.
And then there's illogic.
Right the hand.
I want to give
I have a question.
a chance to respond, and then what I want to do as well is Paul has been patiently waiting, and so given especially Paul's interesting background as a pilot, after Leo has a response here, I'm hoping to hear from Paul. If you have anything, Paul, on your mind, go ahead, Leo.
So, right the hand. Just a really quick question. Do you know what the difference between classical and non-classical logic is?
You're just making stuff up right now.
Okay, no, I'm literally not. Okay, you can actually take graduate level courses in like classical and non-classical logic at universities.
That's great. You think there's two logics. There's logic, which is based on reality, and then there's illogic, which means it's not reality.
I don't know what to say at this point.
The statement is either logical or it's illogical. There's not degrees of logic depending on your bias or graduate degree. Sorry, man.
Well, no, but there are different types of logic, yes.
Paul, what have you got? If you have anything, Paul, I don't want to force it.
Yeah, I'm just going to address what Ross was saying about the North Star. Yes, once you get below the equator, you can't see the North Star, but sailors back in about the 1700s, they used to use the Southern Star, which is Polaris Australis or something along them lines. So they used to navigate by that. You live in Australia. You are in the perfect position to test whether the navigational charts follow the globe. Because if you get a navigational charts, your longitudinal lines will get narrower as they go south. Our longitudinal lines get narrower as they go north. So if you get the navigational charts for Australia and check that out, that will follow exactly what is on the globe, and them lines will match up exactly where they are in Australia.
Well, that sounds reasonable by way of ancient superstitious navigation of things, but
no, that's the navigation that is used today.
In reality, there is no southern pole star that you called it. It's actually called Sigma Octantis, and it's not visible to the naked eye, and it's allegedly supposed to line up in some fashion with the Southern Cross. Now, I see the Southern Cross every night of the year, all year round, in roughly the same position. Its angle does change. But what doesn't change is that by the morning, when I see it in the southeast, when it first comes into view at dusk, is that by morning, when it starts getting bright enough, the stars disappear, it's over to the far west. Now, in the flat Earth model, that works perfectly well because all the stars rotating around Polaris means that because we have time zones, and time zones are ruled over by the sun, wherever the sun is directly overhead is your local 12 p.m. And so as it takes 24-hour segments to go right around the whole world, the other half of the world is in night. And so as the stars are basically working in unison with the sun, that means that the other southern continents will see the same stars that we see during their local nighttime. So for me to see it going to the west is exactly what you'd expect to see of all the stars rotating around Polaris above the stationary planet Earth. The only reason they appear to be going in the opposite direction is because in the south, we have our back to Polaris and we're looking at them in the different direction. So when you look at anything rotating around above you, if you turn around and look the other way, it will appear to be going the opposite direction, but they're all still going the same way.
It won't have an additional rotational pole unless you're looking at a 3D object with more sides than would be available to a hemisphere, which is all a dome over a flat Earth can be. You need to have an entire sphere of the Earth in order to have two rotational poles. Otherwise, what you would see, as you would see if you look at my animation here, where I'm centered on the South Pole, If you were standing far north in Alaska and looking at the stars, you would simply see them sweep across the sky with no rotational pole other than the North Star. Or actually, in this case, it would actually be Sigma Octantis, because I have this centered in a way that actually makes sense for the Southern Hemisphere on Antarctica.
But you've got the sun going the wrong way.
No, I don't. It is actually still going east to west. But if you actually look at the rotation of the actual sky and the objects in it from the Southern Hemisphere, they rotate to your vision the opposite direction, which is what I've got going.
But that's not the way I see them. I see them going from east to west as well.
I might have it X mirrored because of my software. Let me fix that. Sorry, that might be the case. I might have it X mirrored. I don't know. But yeah. No, it's coming.
Yeah, that's what I said. You just got them going from right to left, whereas I see them going as I'm looking south. From left
but you're
to
looking up. You're looking up in real life. You're currently looking down at my map. So yeah, it is going to be reversed.
Yep.
So the thing is, it's not hard to figure out a geometry that works with the sky. It's really not very hard. The sky is is what's called a celestial sphere. It's called that because celestial means heavenly, and the things in the sky are, according to lots of conceptions from the ancient world, the heavens. That's what you call them. And it's a sphere because you can map every fixed star to a particular location on the sphere, and they all rotate together through the year.
Doesn't make what it is. You can call it a sphere,
the thing is,
it can still be a flat
it's not
plane.
just the thing. It's not named arbitrarily. It's named because every single object on that sphere has a particular location on the sphere that it always appears on in the same relation angularly to all the other stars on the sphere. These are not the planets or the sun or the moon.
Well, that makes a mockery of the globe model, though, doesn't it? Because you're saying that
it depends on the globe model.
The Earth is racing around the sun. It goes about 1.6 million miles every day as the sun is moving itself 500,000 miles an hour. So all the angles of all these stars means that you are saying that every single visible star is moving exactly the right amount, right speed, right angle, right velocity.
That's
all
not
around
what's happening.
Ross, so let's say the Earth moves 1.6 million miles in a day, right? How far is it to Proxima Centauri, which according to the standard model is the closest star?
It's about 70 miles, the same place every star appears, because that's where every.
No, I said according to the standard model. It's great that you have a different answer. But according to the standard model, how far away is it?
I really wouldn't know because I've grown up from childish fantasies. You tell me how many
25 trillion miles.
Hold on.
Right.
We do want to hear a response. So just to be sure that we're not cutting each other.
Well, the response was, I don't know.
Well,
it's 25 trillion miles.
We do
trillion miles.
Listen. I don't like that. So just if I say we need to hear a response from somebody, we need to hear them finish, and they'll do the same for you, and I'll make sure that that's the case.
So Ross, what is that
25 trillion miles. Who measured that with what tape measure? What laser measurement device? How did they actually measure this? This is what I'd like to know. You tell me who came up with this measurement and how they did it.
Okay, well, Ross, that's a separate question. Right now, we're trying to get at why it is that the relative lack of apparent change in the location of the stars throughout the year relative to each other is in fact not a problem for the standard model. Now we can figure out how.
You had to back engineer this standard model of billions and trillions of miles to explain the lack of visual parallax, which doesn't need to be made up if you understand that all the stars move as one body around Polaris.
Maybe, but we're still at the point where we're explaining the actual model as it exists. Because here's the thing. This is to all the flat earthers out there, not just on this panel. If you want to attack a scientific model, you have to first understand it. And it is evident that Ross here does not.
I understand your model perfectly, mate. That's why.
Ross, do you think that there should be a difference in visual angle between us and Proxima Centauri after one day traveling 1.6 million miles when the actual distance to it, according to the model, is over 1 trillion miles?
Well over.
According to the model. So that means you have to make up this fantastic belief in order to explain away.
Even if that's what even if that's what happened, Ross. Even if that's what happened. Even if what happened was we just made it up. Look, Ross,
you really believe.
All right.
Even if it were made up. Sorry.
All right. Let's hear from Dapper, and then I promise we'll come right back to you, Ross. Go ahead, Dapper, and we'll let you finish, and then we'll come over
So
to
the
Ron.
point here is, even if it were made up, even if someone just pulled these numbers out of nothing because they helped the model work, it still means that your supposed objection to it fails because the model predicts what we actually see. Now, if you want to have a separate discussion as to how this distance to celestial objects are measured, that's great. But what it still means is your objection that the night sky doesn't sufficiently change based on the heliocentric model is incorrect. The heliocentric model accurately predicts the location from day to day of every star and planet in the sky. That's all I have.
Well, there you go, though. You're saying that it accurately predicts it, but you've based it upon a false notion, which you refuse to acknowledge is the most important reason why you have this belief in the first place, because you can't tell me who did it and how they did it.
Did what?
You just believe they did it, and you have to have a belief, blind faith in this model for it to actually work for you. Whereas we can see with our own eyes. We can't see trillions and trillions of miles away. We can only see a short distance. We can see maybe 100 miles if we're lucky with the naked eye.
I routinely see many trillions of miles.
No, you don't. You believe you do because that's what you've been told to believe, but you cannot see that far.
Yes, we can.
If that light was traversing that much distance, then the entire night sky would be absolutely super illuminated by all the light of all the different stars.
No, it wouldn't.
Why?
At all different moments. Why would you just see tiny dots then?
The whole
If
night sky wouldn't be
miles away,
illuminated.
they vanished into nothingness. It would be pure blackness, or you'd be pure white, bright, lit everywhere.
Ross, are you unaware of the inverse square law as well as the fact that there's a cosmic horizon?
The inverse square law would render them into invisibility.
I'm sorry, say that again. I didn't hear it. I'm sorry.
The inverse square law would render them into invisibility immediately. It's too far.
Which is why things that are too far away are in fact dim, but things that are extremely bright and not too far away are visible. And not too far away, given how bright some of these objects are, turns out to be many trillions of miles.
Well, you brought up the inverse square law. You tell me how it works. Does this mean that if I've got a bright torch 1 foot away from me and I move it 2 feet away from me, it's only half as bright? Where does this inverse square law?
No, it'll be about a quarter as bright.
At what distance? It's a quarter as bright 2 feet away.
Yeah, because if you're doubling the distance, then you have doubled squared for the brightness. For the decrease in brightness.
So by the time I've moved it 20 feet away, it should be completely black, and yet you can see a torch.
So if you move it 20 feet, you've moved it 20 times, right? So what is 20 squared?
400. What's the point?
So if it's 400 times as dim, is that 0?
Pretty much, yeah.
No, it's not. It's measurable.
Torch.
Yeah, it's definitely measurable.
It appeared to be the tiniest little dim spark, as opposed to the bright.
Do you understand how bright objects in space-time are? If you could rank stars on a scale from 1 to 7, with 7 being the brightest and 1 being the dimmest, the sun would be a 3. Look at how bright the sun is during the day. Take an object that's 1,500 times as bright as that and put it 2,000 times further, and you will still be able to pick up that object in the night sky.
Are you saying is the sun not the brightest thing we know? Are you going to say there's something?
The brightest object that we've ever measured? No, that would be a quasar that's like 900 trillion times as bright as the sun that lies about 13 billion light years away.
Who's the you there? I'm sorry.
Leophilus, you yourself, you've seen something 10s or 20 times brighter than the sun? Yes. Or is this just a story somebody told you and you're believing?
No, I've seen it. I've seen the pictures of it.
What is you've seen with your own eyes? Oh, you've seen a picture of it. Was the picture brighter was the picture that you saw so bright it burned your eyes, or was it not as bright as the sun?
Wait, is that how you think pictures work?
No. Well, how do you think brightness works? You told me you saw something.
But you think the way the brightness works in reality translates to
time out. Let me get this out. You said I've seen something 100 times brighter than the sun. And then you said, look at this picture on this piece of paper, which is not nearly as bright as the sun. And I'm going, so then you didn't see something brighter than the sun. You saw a picture, and then you believe that picture somewhere out in your imagination land, there's something brighter than the sun.
So the universe is imagination land now?
Well, the sun is in reality. The thing.
Yeah, the sun is in the universe. Yes.
Hold on.
As is the Earth.
And yeah, and that thing you've said you've seen
is a quasar that's also in the universe.
And it's brighter than the sun?
Yes, it is. We can measure it.
That's why I see the sun.
Measure its intrinsic luminosity, and the amount of electromagnetic radiation that it emits is 900 trillion times more than what the sun emits. Yes.
Okay, so what you're telling me is that some little speck in the night sky is brighter than that gigantic illumination ball that comes during the daytime. That's your argument, and
it's further away
with that. It's a good one though.
Yeah, yes, but obviously, given that it's 13 billion light years away, it's not going to appear in the night sky as bright as the sun. Okay, but so if the Earth were the same distance away from that object that it is from the sun, that object would be 900 trillion times brighter than the sun is.
Yeah, and if. But in reality, so without the ifs.
No, in reality, because we've seen it and we've measured it.
Okay, wait. So we're measuring brightness, okay? Now, I measure the brightness of the sun. It's off the freaking charts. Now, we go at nighttime.
Really not.
Hold on.
It's not at all off the charts.
Wait. Let me get this out. Come on, guys. Come on. I can be the only excited one. If we get too many people excited, it goes crazy. So I measure the sun, right? And the reading is off the chart. Right. Then at nighttime, there's this little speck and we get a reading and it's barely it's a dimple. And you're going, you see that dimple? That's 9 trillion times the sun. And I'm going, bro, I think you've been sold some magic beans.
Can I ask you, do you know what the term intrinsic luminosity is?
Bro, do you know what reality luminosity
is? That doesn't answer my question.
No.
Do you know what the term intrinsic luminosity means?
You're creating brightness that isn't there in your imagination.
I'm only going to try one more time, and more for the audience than anybody. Just pay attention to this. He's not answering the question. I'm going to try one more time. Do you know what intrinsic luminosity is?
Okay, you're kind of doing, don't interrupt, please. I'll answer you. You're doing that thing again that you did with logic. Luminosity or brightness doesn't need anything in front of it. Okay, hold on. When you're saying this thing is bright, okay, that's how we measure how bright it is. Now you're saying, well, it's further away, it's blah. You know, when we're talking about the brightness, which is a visual aspect, okay, visually, the sun is brighter than anything we've ever seen. Now you're converting brightness into a formula and then making the sun the least bright thing in the sky. That's insanity. That's the wizardry of mathematics.
Wait, what? The least bright thing? First of all, not only do you not know what intrinsic brightness is, you seem to think that we think the sun is the least bright thing in the sky. It's not even close. Exactly. I am. See, this is what I meant when I said in my opening.
About distance. I said nothing about distance. I said brightness.
This is what I said.
Brightness is related to distance.
Yeah, but here's the thing. You're going to try and convince me that something that is barely visible in the night sky is brighter than the sun. And
just because it's far away.
Well, that's you. But okay. When you say, but it's far away, that is you saying this thing is not as bright as the sun, but I believe it is. Brighter. But it's further away.
No, you do realize
so exactly. So in reality, I'm going to say the sun is the brightest.
Do you know how we
basically if you look at the sun and how bright the sun is now, and then move it trillions and trillions of miles away, it's going to look dimmer, but it is still going to be the same brightness as it was when it was close to us. It's to do with the distance.
Yes.
Can you move the sun? Can you move the sun?
The sun is moving right now. If you could move the sun that distance, it would be dimmer, but it would still be the same amount of luminosity.
Can you do that to confirm?
Yes, we can. We already have done it. Astronomers do it.
You're telling me you can move the sun and confirm.
Confirm what?
How do you know what the sun will look like 7 trillion miles away? Are you just using imagination?
Because we can look smaller and dimmer.
Because we can look at stars.
Okay, hold on.
We can look at stars that are of the same relative brightness and measure their distance and learn what the sun would look like, since it would have the same relative brightness as the stars is. We can then figure out what the sun would look like if it were that distance away. This is how we measure objects in space-time.
Okay.
You know what we can also do?
When you say figure out, that means I'm going to look at the sun, then I'm going to take a piece of paper, and I'm going to take a piece of pen, and I'm going to do this, and then after about a minute, I'm going to say that thing in the sky that isn't as bright as the sun is brighter than the sun.
Well, you're being a bit hyperbolic with how
No, I'm
easy
being
you think.
truthful.
Please don't overtalk
That's
me.
what you do.
You're being a bit hyperbolic with how simple you think the mathematics is done. It's not done that simply, but essentially, yes, that's what's done. Most objects that we measure in terms of their brightness in space-time, we measure against the sun. The sun is the standard for our conventional system.
Excuse me, can I just say something here? This is a flat Earth debate, is it not? And yet here we are talking about the lights in the ceiling. Like, we don't look at the lights in the ceiling to determine the shape of the floor we're standing on, do we? So we can look at the stars and the sun and all the discuss its brightness as much as we like, but this is really getting off topic about
Actually,
talking about
I
the flat
can
Earth.
look at the
Where we
lights
know
in the
that
ceiling,
water makes
even in a
level.
room. Even in a room, I can use the lights in the ceiling without ever looking down to determine the shape of the room, as long as I'm able to measure the angles to them and notice how they change as I move across the room. It's actually
Gotta
not
love
very hard to.
calculus.
Yeah, it's not very hard to use. Just, you didn't need calculus for that. All you need to
Yeah,
do
but
is
most observation
notice
points are stationary.
you're
so,
moving around
you're
to
not
different
even gonna move
locations.
across the-
if you have
Yeah.
if you have a ceiling and you move to different locations and you measure the angles, you can get a actual in 3D map of the ceiling, and then based on that, you can backtrack to where you are in the room and measure the shape of the room without ever having reference to
And determine that the floor curves. Is that what you're saying? That by
If the
measuring
floor
different
does
Let's
curve,
talk
then
about
yes,
that
you
base,
would.
please.
Yeah,
Yeah,
if
I
the
think
floor does
make-
curve, you could determine that. Yes.
on a desk and shine a lamp above them and get heaps of different angles of shadows, and I can use a mathematical formula to prove how spherical my desk is. It doesn't
No,
prove
you-
that my
you
desk
can't.
is big. And
You can't do it with a flat desk. No. Now, if you had a curved desk and you actually moved a camera
No, if I
facing
had a
lens
flat
across the
desk-
curved desk,
if I have a flat desk and I have a fixed lamp above it, and I line up a pile of just say batteries, stand them up end to end, end on their end from one side of the table to the other, and I measure all the different angles of the shadows, I can use a mathematical formula to prove that that desk is spherical.
No,
I
That's
encourage you
basically
to do so. I
Not if
await
the
your
desk is
monograph
not
That is
spherical.
the Aristotelian
bated
experiment in a nutshell. So it doesn't prove anything. It just proves that you've got a local
Ross-
light source and cast different angles of
So-
shadows on different things.
So
different
here's the thing,
locations.
Ross.
Oh,
You
my
say that
lord.
you could do this. I say you can't. But the simplest thing to do would simply be to do it. Get a desk, get a lamp, get a camera, get something you can use to help measure angles, and do the experiment, and then publish your results, and then let other
You can do
people
that
check
with a
work.
simple protractor. You can use a simple protractor to measure the angles.
Okay,
and you
well,
could
why
plug
haven't
it into a formula.
Yeah,
Why would
haven't
I?
you?
Because it's ridiculous. You know, I
Well,
understand.
because
that
you
the
think-
But you're
flat-
saying it proves your point. So why would you not have done that experiment that you're claiming proves the point that you're trying to make?
Because it's already been
go out
done.
and do the work.
Aristotle's did it, and he proved that we have a near local sun. He didn't
No,
prove
wait,
that the sun was
he didn't.
93 million miles away.
Aristophanes proved that the surface of the Earth is curved, that it's convex.
No, he proved
No,
that
yes.
different
Yes,
places,
he did.
different locations will have different angles of the sun on the same
Yes,
day because the
because
sun's nearby.
the surface of the Earth is curved. Yes, you are correct.
How did,
No.
how did he
Different
come up with
angles
that
because
geometry?
because the angle of incidence changes. Yes. Yep.
So you're saying the desk is curved to give different angles from each different battery from a fixed light source at the same time.
No, it's different on a curved surface.
You are saying that.
No, I'm
That's
not.
what
Leo,
you-
can I just
conclusion.
sorry, can I just ask Leo, how did Eratosthenes come up with spherical geometry
Well,
when it didn't exist?
I don't think spherical geometry was invented by Aristophanes. He used simple trigonometry.
That's
when-
with
when
triangles
when you
with
talk about-
180 degrees, like I keep saying, Euclidean geometry.
Of
You can't
course.
curve those lines in triangles.
You don't need to determine that the Earth is curved.
Okay, well, can
But
I
simple
like,
trigonometry has straight edges. How
can
can
we
you
go
use
back
it
to
for-
that base?
Okay,
was
hold on.
The
Can
next
I-
point I wanted to go to.
So no, really quick here, Bev, because this will help make my point. You see the curve in the second image you have there in green where it says hump. You see that curved line that you have. Can you draw a secant line through that for me, please?
It's there. The bit
you
where
draw-
it says hump.
No, the line.
Like,
the
see that
curve-
little bit there? It's where it says
Yeah,
hump. That's
but-
that's the bit above the horizontal that is
I'm-
set by the
I'm-
water level.
I'm trying to make a point.
Hydrostatic equilibrium.
I'm trying to make a point here. The curved line under which the word hump is written.
Yeah, see that,
That
little line?
line.
It's already
Yeah,
there.
okay.
That's
I'm
the
not asking
amount
about
of-
it. I'm
of
asking a question.
distance.
Can you draw a secant line through that?
It's
through
there.
that curved line?
Drawing there is
Can
hydrostatic
you draw a secant line
equilibrium
for me?
line
please?
there already.
Do you understand what I'm asking you?
What, do you want to do it?
I can,
Well,
but it's going to take a
do us
second.
do us a quick drawing then.
It's going to take a second, so somebody else can go while I get it set up.
Okay. Well, that's what I wanted to go to, was the because you said something earlier about hydrostatic equilibrium.
Yes, I did.
Proving a curve or something. But that's the water level is establishing a horizontal plane of reference, right? That's a
Level is the
horizontal is
curve.
a straight line, right?
No, it's
It's
no.
level with the surface of the earth.
Yes.
whatever the shape of the
What does
earth
level
is,
mean?
that is the shape of level. So
Yes.
saying that water is level provides you with no help. You still have to go out and
No.
actually measure
Gaffer,
things.
what I said was a water level
Okay.
is a tool for establishing a horizontal plane of reference, as is all tools that are called level. They
Okay.
establish a horizontal plane that is parallel to that of the plane of the horizon. All horizontals are parallel to the plane of the horizon.
That is how they're defined. And your horizontal on different locations will depend on the shape of the earth. If the earth is in fact flat, then yes, all horizontals will be parallel. If it isn't,
Water level
it
just
won't.
proves that wrong. Water
No.
level just proves that level is universally level. That's why we use the term.
Of course it's
flat
universally level.
and level.
But the
Because-
question is whether or not
So that
level
means
curves.
horizontal.
It doesn't
That's
curve.
right.
Why not? How
And
do
it
you know?
doesn't curve because
It's a
flat
horizontal
and
plane
level.
of reference. It's easily provable, as is
It's
every
not,
time
though.
any surveyors ever do a job. That's what
Well,
they use.
except,
a horizontal.
except you don't believe surveyors, because when I report to you the actual finding of surveyors, you just tell me that it's wrong and don't give me an explanation. So
Dude,
please,
you did
don't
just
come,
say
please,
those
please,
surveyors.
Let me finish. Please don't come to me with surveyors when you think that either they're just making stuff up or they're lying or I don't know. But you apparently think that surveying is just nonsense. So I don't know why you're trying to use it on me. But the fact is that whether or not level is curved depends on the shape of the earth. So saying that it's level doesn't do anything. It's agnostic to the shape of the earth. Pointing out that level exists helps neither you nor me. You have to actually do some actual out in the real world measurements, which
Okay,
is my
can I
which is a big
answer
part of
that
my
now,
point.
or are you just gonna?
Yeah, sorry.
Level is horizontal. Right?
Prove it.
It's not something you have to prove. It is an established fact.
Is it? Because
Yes.
definitions of level don't actually prove that or demonstrate that fact.
Really quickly,
How
I
would
just
you
wanted
level
to.
a circle? Could you level a circle?
Could you level? In a sense, yes. I am sharing my
Okay.
screen. I don't know if James can see it or not, but I
would
can
love to see
explain
all of
how you can do that. Yeah.
Yeah, you can be at a set
Is this
level above a circle.
in
Okay.
relation to a
So-
water level? How can we do this?
So
You can't level a circle because level is an orientation and being straight between 2 points, right? So this is straight but not level. A curve cannot be level. So to level something is to make it straight, not to make it round. Okay?
No, you could be level to the surface of the earth. So you could follow the curvature of the earth and stay at that level.
So
Just like
if
an
you
aeroplane,
hired a
just like an air-
handyman,
Just like an aeroplane, when it flies
let
across
him
the
have a
surface
go.
of the earth, it
hold
stays
on.
at a set level to the surface of the earth.
Really quick, right the hand. Do you know what a tangent line is?
line to a circle.
Well, no,
A line to a circle.
that's part of it.
It's really rudimentary, but
It's a
so
straight line that touches
here-
the
here-
curve at one point only.
Yep.
here on my screen
Off you
we have a curve. I've got, say, a point on that curve, and what I can do, and this is going to be a little bit, is I can draw a line like that. Is that line level?
No,
Well, first off, define what I would need to do to make that line level.
make it horizontal.
But it is horizontal
It's
relative
not
to.
no, that's
It is,
not
but
horizontal.
you didn't
dude.
let me finish. You didn't let me finish. It is horizontal relative to that reference frame. If we were to zoom in on that so that we could look at it here, we would see a straight red line. Would we not?
It's not horizontal.
That's not what I asked you. If we zoomed in on that, we could see a straight red line, correct?
Yeah, it's a tangent.
Okay,
That's what
so
you just
there
said.
is
The
a
tangent's straight
there is a
line.
way.
It's not
There is a way.
horizontal.
There is a way to make it horizontal, is what you're saying.
Okay.
So
Yeah,
this
it's
is
not-
what
it's not
this is
horizontal,
what
it's
we do.
horizontal.
Perspective looking
This
at
is
it,
what we
but
do
if you
on the
were there, it
surface
would
of
be
the Earth.
horizontal.
This is what happens on the surface of the Earth. Water is going to be level along any given tangent line on the surface of the
Horizontals
Earth.
don't intersect.
Well, I think you should probably learn a little bit of advanced mathematics because, yeah, it just does not seem that you understand precisely what you're talking about.
This may be a chance to give you guys a warning that we'll go into the Q&A fairly soon here. So if you guys have any concluding points, things that you for sure wanted to bring up and you were like, oh man, this would be interesting to get the take of the other side on, please do. And then in several minutes, we'll go
I
into
actually
Q&A.
did.
I got one too, and it's
How-
on what we were just talking about. But you,
how do we explain how every other planet and star and black hole and neutron star that we've ever observed is spherical, but the Earth somehow isn't?
Just like
How do you know
the sky.
they are? Have you ever been to any of them? Have you ever landed on any of them? Have you ever
We've seen them. We've seen them.
You can see them.
Yes,
Okay,
we
but
can.
you can see the things. If you could see a truck in the far distance, you see a singular light. As it gets nearer, it starts to break up into the two headlights, a whole body of light. But at a far distance, it appears to be just one orb of light. So you don't really know what you're looking at until you get much
Yeah, we
closer.
do.
But you've already told us that they're trillions of miles away
Wait,
just
do
for the
you
nearest.
do you think that electromagnetic radiation is the only way that we detect these objects? I mean, it's the primary method, yes, but it's not the only method. And why
once again,
is it that
looking at
all the
light
different
and
methods
just
that we
not
utilize for observing these
representing-
objects comport with each other?
Just because they look like orbs of light does not mean that we're standing on a similar type of orb for 1 second.
So then how come every other planet we've looked at and even things smaller than a planet like the moon are round?
Well, the only thing we've seen that we know is round is the moon. Anything else
And
is an
well,
orb
the
of light.
sun, Jupiter,
I've
Venus,
seen with my
Saturn,
own eye, yeah,
Pluto,
several
Mercury.
Orbs of light.
Yes.
Orbs of gaseous light, emitting light. Like, how can you have
No,
a
they
an
have
orb of gas
shadows.
in a vacuum? You cannot. You're just making
Wait,
up
hold on. What did you just say?
an orb of gas in a vacuum. It's impossible because everything in a vacuum.
Hold on. Can you what does a vacuum mean in physics? Can you tell me what that term means when we're talking in terms of like physics?
Means nothingness.
No, that's not
Means
what a vacuum
non-existence
means.
of anything physical. Well, what
That's
does it
not-
mean then?
It means lowest energy state. It means the ground energy state. It is a field in a ground energy state. That would be a vacuum state of that field. And for matter and energy fields in the vacuum of space, there is a very, very, very small amount of particles present in these fields. So we say they're in vacuum state. They're at a vacuum. That is the vacuum of space. You can curve that manifold, and that is why planets and stars and black holes and neutron stars and all the subgalactic objects that we observe are round given their mass.
So you can manufacture anything out of nothing so long as it fits your agenda that you want to believe in. Whereas in actual reality, if we create a vacuum
that's not
state
true.
here on Earth, we need to use powerful pumps, strongly sealed valves, and solid walls to create a vacuum state. And the minute that seal is cracked the slightest, everything instantly wants to equalize pressure.
Of course.
And so even Earth itself could not exist within this vacuum state and still have an atmosphere unless it had a strong physical barrier protecting us from the exterior lack of pressure.
It does. That's called gravity.
It does not.
Yes, it does. It's called gravity.
Hey, it took us over an hour and a half to get to gravity. That's I think that might be a record for the Flat Earth debate.
Gravity in the molten core of the planet. How can
What's
that be
that?
an exterior? Isn't gravity the molten core in the interior of the planet? How can that
That
be
is
an
not what
exterior?
gravity is. Gravity is
Light-
curvature in the geometry of space-time by the presence of mass energy.
So things that get less and less affected by gravity because of the lack of density as they get further and further away from the field of gravity get held by this invisible container because of gravity with the least effect.
Density has nothing to do with it.
Correct. It's got everything to do with it.
No, mass. Mass is what we're
Yeah,
looking for
but
here.
mass is defined by density per volume.
Not in relativity, no.
Yes.
No. Mass is a fundamental property that elementary
Well,
particles
I'm
hold.
talking about reality, not relativity. You know,
Relativity is reality. We use it to observe and study and define our physical models in reality.
Look, you're Ross. You're welcome to overturn relativity when you come up with a model that works better for the things that relativity is used for.
Well, we use
Good
relative
luck.
density, and that easily overcomes your relativity made-up
Nope.
thing to say
No,
that
it doesn't.
things
Because
move relative to one
density requires a force of gravity in order to actually
But that's
cause
not.
the emergent
No.
buoyant force that would
Relative
counter
density.
the actual downward force of gravity.
Relative density is determined by the density of the medium within its end and how much resistant force it has by
Great. Tell you what, Ross,
by
you
the
come up with a
reality of
better
economic
version.
density.
You come up with a better
Well, I
version
just
of
did.
the buoyant force equation that doesn't use gravity as a term, and get back
You
to me.
don't use gravity. What is gravity in your explanations except for it's just a measurement of distance over time?
I literally told you what gravity was. Gravity is curvature in the geometry of space-time by the presence of mass or energy. The Earth is a massive object,
What does
so
that
it
mean?
curves. What that means is that
You're talking about the space in between. Hold on. Are you saying that you can curve the area of space in between my hand? Okay,
Yes.
if you can, hold on. If you can do that, first, tell me what shape the area between my hands is and what shape you're going to curve it into. Are you curving it up?
it would depend on the mass energy stresses present on the space-time in between.
No, the stuff in between. The stuff in between. How are you curving that?
It depends on the stress from the mass energy present in between, because
What does that mean?
About reality. Observable reality says that thing
bending
drops
it with
because
his
there's nothing there
hands?
to support it, to give it resistance.
Hold
So it
on.
reaches a place of sufficient resistance due to its density to stop it from falling any further. That's all you need. You don't need to bend space and time and make up all sorts of nonsense things. Occam's razor says the simplest explanation is generally the most correct one. The most correct one says if you've got sufficient resistance
That's not what it
density of the
says.
medium, then you'll get buoyancy. If you have insufficient resistance from the amount of density, then it will continue to drop until a place of sufficient resistance due to the density of the medium. That's all you need. Nothing complicated, no bendy space-time or anything above that. Just resistance from relative density.
What you said is not correct.
Can you bend the space?
Gravity in that.
If you measure the distance between my hands, can you bend that distance and make it shorter and longer?
Yes, I can, but it depends on.
So you're telling me
you keep asking the question, but then you keep interrupting the answer I'm trying to give you.
Well, because it's just so ridiculous.
Well, no, how can you know that it's ridiculous when you haven't even heard the full answer because you keep interrupting me every time I try to give it?
Because if you're going to tell me there's 6 inches of space and you can change that 6 inches to 4 inches, you're saying 6 inches equals 4 inches. That's ridiculous.
Well, that's not what
We're not even based in logic right now.
I am sharing my screen because it shows a useful animation of what gravity is in terms of what it does to space-time.
Gravity is a useful animation.
Yes. So if you can see this animation, that object would be a massive body like the Earth, and the coordinate plane that you see would represent the curvature, the warping of the geometry of that plane we feel as gravity. Any object present in that curvature, like if you put a bowling ball on a trampoline and then set a marble on that trampoline, the marble will roll toward the bowling ball. It does so because the geometry of the trampoline is curved inward toward the bowling ball. Well, gravity curves the geometry of space-time inward toward that massive body, so that any other body's what's gravity is not strong enough to overcome that field will fall toward that. It doesn't even have to be that strong. The sun is consistently affected by all of the planets that orbit it. The sun consistently wobbles and precesses in its position due to the gravitational pull from all of the planets that orbit it. This animation you're seeing here, this is what gravity is. This is what massive objects do to space-time.
I agree.
This is why gases are held to the surface of the object, because the space-time in which those gases exist is curved inward toward that object, forcing the gases onto its surface. This force is also the reason that objects are spherical, because it pushes inward with equal force on every infinitesimal point on the surface, but the resistive force pushing back outward gives rise to a state called hydrostasy, or hydrostatic equilibrium, and that is best served in a spherical form due to conservation laws like energy and momentum.
except for Earth, which is oblate. But your description of gravity just then destroys itself, because you said with the bowling ball and a marble on a trampoline, that would describe the moon being attracted to the Earth and smashing into the Earth and being stuck to the Earth permanently, not continuously.
No.
For thousands and thousands of years, as we hurtle through this.
Wait, can I ask you a question?
It's in an orbit. It's falling around the Earth. It's in an orbit.
The moon itself just debunks your whole argument, because if we're moving in one direction,
one second, just
hurtling through space on the trampoline while the marble goes around it, because that marble would then also have to be accelerating upwards with the bowling ball, which is what you're saying the moon is doing. As the Earth travels multiple different directions, the moon therefore must be accelerating and decelerating the entire time that it is chasing us as we're chasing the sun, which that is impossible.
Can I respond to that really quickly?
Because we haven't heard from Paul for a while, I do want to get to hear from Paul before we go into the Q&A.
Well, I'm no expert on this, but my explanation for that would be the moon is a satellite. It is orbiting the Earth. It is falling around the Earth. Because of the speed that it's traveling at, it never hits the Earth. It keeps missing, so it keeps going round the Earth. That's what's going on. And what Leo Phileas just showed us there with that demonstration, I've never seen anything like that before, and that perfectly explains what is going on. And if you couldn't see what that model was telling you, then I'd give up. This is absolutely crazy.
Yeah, but look, if the moon misses us just that one time, it's going to keep on going in a straight line. There's no reason.
It's not, because the gravitational pull of the Earth is going to pull it back around.
To respond to what Ross said, I can make it like 15 seconds.
We do want to jump into the Q&A, guys. I just because we do have a lot of questions already, so I do want to get through these. I promise you'll get a chance to potentially, we have so many questions, this topic may come up again, so in which you'd be able to get to jump in, because I know that also Right the Hand, am I pronouncing it right, also had his hand up, and so sorry to jump into it, but I want to say thank you for your questions, folks. Our guests are linked in the description. That's no matter whether you're listening via YouTube, Twitch, or the Modern Day Debate podcast. And by the way, if you haven't found us yet, pull out your phone, find your favorite podcast app, and find Modern Day Debate, as we have been excited that people apparently found it useful. So Sigma Any, thanks so much for your super chat. Says predict James will be on time. Ha, very funny. Bumpy Earth 420 says Globe's getting wrecked tonight, especially when the moderation isn't biased. The horizon is not the curve.
I don't know what that
Globies,
means.
are you going to take that?
I don't know what that means. I don't know what they're trying to say. It
not
means
entirely sure what the point was.
Yeah, I think that is to do with the horizon, is to do with your perspective. So the apparent horizon isn't the same as the geological horizon due to atmospheric refraction. So you never actually see the curve. You see the apparent curve.
Gotcha. And Cider
Here in reality, what we see is what we get.
Thanks. I hate to do this, but just because we have so many. Cider Report says, how does the flat Earth side explain time zones? It's 1:20 in the morning here as I write this. So how do time zones work on a flat Earth surface?
I already explained that earlier by saying that the sun is the hour hand of a 24-hour clock. And so wherever it is locally, that's our local midday. Where it is 90 degrees to that one side would be 6 a.m. on one side and 6 p.m. on the other. And as it goes, and the direct opposite side of it would be 12 midnight. So as it moves around, that creates the time zones, which more or less match geographically. They are done to match nations and for political reasons and so on. Like China only has one time zone, but time zones are easily explained by the flat Earth surface basically being the face of a 24-hour clock.
Gotcha. King024, I hate to do this, but we have so many questions. It says,
it's all good. Go
question
ahead.
For the flat Earth people, please make a novel prediction using your understanding of the flat Earth model that can be used in real world scenarios to figure something or anything out.
Timeanddate.com is a flat Earth map, square, flat. It'll give you sunrise, sunset for the next 30 years. It's flat. There you go.
Juicy. Sigma Any, thank you for your question, said, Ross, did you get a chance to Google theodolite? Since our pre-debate debate, some research into professional measurement tools is in order before claiming to understand more about measurement than a geospatial engineer.
I'd already explained how the theodolite works to him. It's simply a basic way of overcoming the limits of our human vision when we're looking into the far distance. When we look into the far distance, everything converges at eye level, which is what horizontal is all about. As the video I uploaded due to that discussion before this debate started on my channel shows perfectly how it works. The theodolite simply shows how your elevation would actually appear at that far distance where the convergence point is, because we know we're higher than the water level beneath us. It just appears to come to eye level. The theodolite overcomes that visual limitation and shows you what your actual level would appear to be.
Everything
Gotcha.
he said was wrong, completely
I hate to
wrong.
do this, but I have to jump to the next one because we have so many questions. Cider and Port says Ross sounds like an Aussie, or Aussie, that's right. Even if he isn't, my question is, Australia has their summer during the winter months. How is this possible on a flat Earth?
Okay, well, I've also tried to explain that briefly in my introduction, and that's simply because the sun moves in a spiral around us, around the equator, and it moves upwards until June 22nd. That's the highest point. And so when it's furthest away from us, it appears to make a much smaller circle. So when it's further from us, then it's direct light coming through the angle of our atmosphere after the firmament means that the light is diluted a lot more, so we get less heat. So that's why we're having winter, while the inner side has the direct light straight through to it, so it has summer. And as it spirals back down again, it appears to make a much bigger circle, which goes out to the Tropic of Capricorn. And then the light is coming through less atmosphere directly to us, so it gives us summer. And you'll notice that in the southern side, we have much longer and hotter summers than the inner side do. They have a much shorter, moderate one.
Next up,
But the sun changes
Kango24.
speed then.
Kango24, thank you for your question, said, watching a quote-unquote adult man pouring water over a little ball and shaking his head is quite possibly one of the saddest things I have witnessed. I can't remember who did that. Did anybody do that? I don't remember seeing that.
That was right the hand, but I want to say, to be fair, I believe it was a fruit and not a ball. So let's get our criticism correct. It was a fruit.
Right the hand. So sorry, buddy. Teasing is a love language, Kango24, Sigma Any says, Bev, are you the same Bev, in parentheses, on the level Bev, that attempted to challenge land surveyors on Reddit about how to make common measurements such as level?
I asked them about my test. Well, it's a straight line proof test using water levels. In reality, using practical geometry, yeah. And the trolls hit us really hard.
What you have on your board is incorrect, by the way.
This one from Kango24 says, got that. Chris Gammon, good to see you, says, flat earthers. Fast jet with unlimited fuel flying straight at the sun will take you around the globe to where you began. The plane didn't turn. Explain that.
The plane did turn, because if it's following the sun is going around the equator the whole time. Even though you might see it through a different angle you might see it through a different angle through the firmament, but you're still going westwards in a great circle. So you might think you're not turning, but if you're following the sun or you're following a compass, you are making a very slow, gradual turn, which will bring you back to where you started.
Gotcha. This one coming in from Kango24 says, the sun does not change angular size to an observer as it sets, so it's not moving away. Question for the flat earth people, please explain a sunset.
Well, that's quite easy as well, because we are seeing the sun as a hotspot apparition through the firmament. Now, as I described the firmament as like a big sheet of ice above us, once it hits that sheet of ice, it's still going to create the same size apparition, regardless of how far away you are from it. It's just that as it gets further away, it's going to get lower and lower until convergence obscures it from your point of view, and then the light itself will no longer reach us, and so it goes dark, and that's what we call sunset. We have long drawn-out twilights as well, which you cannot possibly have on a globe Earth, because if the globe was spinning, as they say, at over 1,000 miles per hour, going the opposite direction away from the sun, the shadow of the Earth would instantly render you into darkness, and you would not have a long drawn-out twilight. You'd be instantly in the shadow.
Question for Bev. They're coming after you, Bev. This is from Kango24, who says, are you familiar with non-rational B-splines? They are geometrical primitives used for making lots and lots of real-world things. Okay,
yeah, I'm just, all I do is the real basic stuff, just talking about basic horizontal and water levels.
Gotcha. And Mark Reed says, Ross, you are Australian. Why can you not see the star Polaris from Australia? Why can't anyone in the UK or North America see the Southern Cross?
As I already explained, distance makes things disappear. As you get further away from things, they appear to get lower and lower. The stars are not immune to that natural law of perspective. It's the same as if you move away from a mountain, that mountain will appear to get lower and lower until eventually it's obscured by the convergence point. The stars do the same thing, and basically the equator is the cutoff point from where you.
What is that distance?
Well, the equator is a distance where Polaris disappears from view. What is that? 4,000 miles from the North Pole? Yeah.
That's not a large distance.
About 5,500, because it's not the radius of the Earth, is it? It's greater. So,
okay, so what you have is a post hoc justification that doesn't match observations. Okay, that's fine. Anyway, continue. I'm sorry to interrupt.
Next one coming in from B-Ball for Life says, Bev, why do surveyors' manuals say geodetic surveys of large areas are affected by and must take into account the curvature of the Earth, location on the Earth, surface, and elevation above sea level?
The elevation is measured from a horizontal base, from the datum on a vertical datum. And I think what he's talking about, they say over 100 square miles, I think. Any project over 100 square miles is where they take into geodetic. Anything under that would be classed as planar surveying, as are all the tools are planar surveyor tools.
No, they take it into account when making bridges. They don't have to be over 100 miles.
This one comes in from Decepticons Forever, who says, how do tides work on a flat Earth? Right the hand.
Oh, yeah, that's an easy one. So my flat Earth is the Pac-Man, right? Probably heard of it, Pac-Man Earth. Things just go from one side to the other. I'm working on the portal, whatever, why. So picture a wave. If you had a wave that just went across, the down part of the wave is your low tide. And then as the wave comes up, that's your high tide. So if you had a wave slowly moving across the flat Earth or the flat plane Earth, you would have high tide where the crest is and low tide where the valley
What causes the waves?
Bro, you're asking me like what causes the sun? I don't know.
I can tell you what causes the sun, actually. Gravity and gaseous clouds. But what causes those waves?
Gravity and gaseous clouds.
Where did those waves come from? Did they just magically appear, or did something create them? And if so,
well, maybe the wave has something to do with the sun moving over the.
How would the sun cause the waves?
How does space-time bending change?
Ross wants to add some as well.
High tide at night.
Sometimes things,
let's hear from Ross.
I have a very real explanation for why the tides exist on the planar Earth, and they are linked exactly to the moon. The moon is held aloft above it by a weak diamagnetic force, which as it revolves around us, it's a repelling force. You cannot pull water, but you can push water. Try using a straw above a glass of water and try to suck water in with the straw above the water, but then try blowing on it, you can easily repel water. So what the moon is doing by this weak force is actually pushing the oceans around in front of it. Now, as it goes around on a circuit, of course, it hits the coastline of a continent, and the water can go no further. That's the high tide, and then the water starts receding and going back. Water has a backwash effect. It's part of dynamics, fluid dynamics. And so as the water goes back again, it creates a secondary high tide back on the opposite shore from which it came. by which time the moon has made a full circle 24 hours, 50 minutes later, and starts repelling it forward again to create the next high tide back the other way again. So that's why we can get 2 high tides and 2 low tides every single day on the stationary planet Earth, but you cannot have 2 high tides and 2 low tides on the globe with one moon pulling the oceans in one direction. You get one massive high tide and one massive low tide every 24 hours, 50 minutes. But
any
this
thoughts,
matches
Paul?
the moon cycles 100%.
We haven't heard from you for a while, Paul. Go.
No, I haven't got any thoughts.
Dapper?
This is the maddest thing I've ever taken part in.
Dapper, are you still there?
I am sorry. Yeah, I was muted because there was a dog barking. So I will give Ross this. He at least actually answered the question, but again demonstrated a complete lack of understanding of the standard model which he's seeking to criticize, which in fact does account for the just over twice daily tide cycle, because the tide cycle doesn't take quite 24 hours. So yeah, it's just another example of the flat Earth side just failing to actually understand. Oh, sorry. Yeah, you're right. So it's just another example of the flat Earth side failing to actually understand the model they claim to be criticizing. So it's very frustrating.
You have no explanation for the secondary high tide.
We should jump into the next one.
That the Earth is pulled through the ocean for the second one.
Gentlemen, we should jump into the next one. But John,
can I give a response? They can make it quick, really quick.
I hate
Very
to say
quick.
no, but we have a lot of questions. Do want to say we appreciate your question, especially it is for you, Leo. Cider and Port says, for Leo, in your opinion, why is there a correlation between someone's opinion on the flatness of the Earth and this? Okay, gosh, looking for more serious questions. Leo, will give you a chance to respond since this wasn't a serious question. What did you want to say?
So the reason that tides exist is because of the gravitational force that the moon exerts on the Earth. So I believe Ross is the name. He is right when he says that it is the moon, and it is a result of the moon orbits the Earth slightly faster than the Earth rotates. And as the moon comes around the Earth, the ocean tides, and obviously I'm exaggerating, will move upward toward it due to the gravitational pull, and that results in what we call tides. And this is why other gravitational forces that can even actually physically stretch and move moons or other planets, like we see with some moons of Jupiter, this is why we call them tidal forces or tidal effects, because they result from gravity.
You've got 2 moons in the one day, 2 tides, but there's only 1 moon. Where's the second high tide come from?
It's emergent from the fact that when water is pulled in one direction, it has to come from the sides, and that lateral motion is differential to the opposite side of the bulge, which means that relative to the low tide, there is a less high but still high tide opposite the moon, which the high tide itself is offset due to the rotation of both the moon and the Earth.
No, that would be the low tide.
I know that's what you think, but that's not what the model is.
We must go to the next one. John W. says, I love this channel. Respect to you, friends. Even if I do not agree, I love hearing ideas and knowledge. John W., thanks for your support, and you can find all of our guests' links in the description. And Titanicus Andronicus, thanks for your question, said, if equations are wizardry, then algebra is black magic. Great show. Thanks for that. And John W. says, globe Earth, but I may be ignorant. It just makes more sense. Love the debate. Thanks so much. Appreciate it, John W., for your support. The Crawdaddy says, I like flat earthers. Let's see.
Okay.
Hey, James. James, do you mind if I quickly address that first comment you made about the black magic sort of thing?
Go ahead.
Because it's quite ironic is that the globe depends 100% entirely upon this black magic, which they call the dark force or dark energy, dark matter. And they say that it's 70% stronger than gravity itself. So first they invent gravity to make the world possible, but then to make the universe possible, to stop it all colliding into a singularity, they use this dark force or dark matter, which has never been seen, but they can tell that it exists because of their wizardry and formulas.
Next up, B-Ball for Life says, the stars are 70 miles away? Wow. So the stars are closer to me than California, and I'm Hawaii? I think they're saying I'm in Hawaii. I don't know. But they say, are the stars closer to B-Ball for Life than California is?
what I was saying is the apparition of the stars are 70 miles away. The true star might be any given distance above that we would never know, because the firmament is the place where we get the first reaction of the electrostimulation of these various things that create the energies that create light in the firmament. Then with the sun, of course, being the greatest of them all, and the stars, but they all appear in the firmament, which is why the ancients have always said that the stars and the sun are in the firmament, because that's, to all intents and purposes, where they appear to us, in it, whereas they could be any massive distance above it.
John W. says, I am more interested in the awesome work of the middle guy on the whiteboard. Well, so it's been interesting to see the different gadgets and things on screen there. Mr. Wilford says, for the flat earthers, explain in particular, Right the Hand and Bev, why standard candles don't allow us to say stars are millions/billions of light years away.
So is this guy's argument because there's candles that a star is 1 billion miles away?
Wait, you don't know what the term standard candle means even? Oh, wow.
So candlelight luminosity. Okay, so things have
really harsh.
Bro, because I didn't hear what he said, bro. Chill out. So because something has a candle watt power and we call the brightness candle watt, that means something can be 1 trillion miles away.
No, that's not what that is.
No. All right, yeah, okay.
Let's hear briefly, Dapper, if you're willing to share what a standard candle is, and then we can give a chance from Right the Hand.
So a standard candle is an object of a known absolute luminosity. So we know exactly how bright it is from a given distance. And then when we see that particular object, we can measure its apparent luminosity and then use the inverse square law to calculate its distance. Because if you have its apparent luminosity in the inverse square law, you only have one unknown variable, and that's distance. You just rearrange it with algebra, you get the distance.
Yeah, so have you ever gotten right next to the sun and then walked 10 feet away from it and know what the brightness
nothing to do with what he
hold on. Let me just say. Or are you saying because a candle behaves like this, the sun, which doesn't sit
Why are you stuck on candles?
Hold on, bro. The sun, which doesn't sit on a desk burning wick, should behave like the candle. That's ridiculous. When you have the candle or any type of candle light, floating in the sky above me, then I'll believe that stars are millions of miles away, man.
You're a Poe.
I'll tell you what,
have to be a Poe.
Right the Hand. When you figure out a way for the sun to work differently that doesn't involve special pleading, let me know.
You're saying every day we wake up and see a sunrise and a sunset, and you're going, how does that work? Bro,
no, I know how it works.
How things work. You just see that they work. So when you so when you ask me how does the sun work, you're somehow thinking that you can see why something happens and the thing that happens. No, you see the sunrise and the sunset. That's it. Now, if you want to believe that's because the ground you stand on is spinning, that's fine.
I'm going to cut in.
That is what,
this, but Sigma Any, thanks for your question. Said human beings are intriguingly diverse critters. Thanks for that. Kango24 says, for Bev, do you understand the difference between objects that are small and objects that are far away?
You have some Father Ted here.
Difference between them. Yeah, of course.
For all intents and purposes, it's the same thing, isn't it?
Did he give you a lot of money for that?
I'm sorry, I need to mute myself.
The large thing will look very small further away, whereas a small thing will look quite large up close. But it's all perspective, isn't it?
Wait, hold on. Just really quickly. Can I ask you a question?
The small thing will be even smaller when it's further away.
This can be really quick.
Questions.
This is really quick.
10 seconds, Leo.
Yes. Ross, so does that mean that a sphere can look flat really close, but far away it can look spherical? Because that would follow from what you just said.
But you'd still see curvature because any sphere, by definition, has.
So you're conceding. All right, you can continue, James.
A sphere is the surface of constant curvature.
You got to let him respond. I don't know if he's done. Go ahead, Ross.
I was just saying, a sphere, by definition, has sphericity or curvature in all directions. It doesn't just exist in the far distance where it's out of sight, out of mind. You must be seeing it left, right as well for it to be spherical.
Yeah, he's conceding.
What you will see on the sphere. You will see that on any
board. A little bit impulsive, buddy. I hate to call you out for that, but jeez. All right, John W., thanks for your question. Says, I am driven to drink because this is my life the way it is. but flat Earth versus globe. Thank you for that. T Fish says saying anything is over 1 trillion miles away is a maniacal fantasy. I don't understand how this is even a debate anymore.
I'm sorry, the big numbers confuse you.
Yep.
That's all I got.
Decepticons Forever
big
says
numbers are confusing. We don't understand big numbers.
we must jump to the next one. Decepticons Forever says Emil from RoboCop doesn't understand distance. Sad. Who's Emil from RoboCop? Next up, Chris says, question for Globers. Which unis did you guys learn this mysterious math wizardry I've heard so much about? Hogwarts?
The University of Massachusetts in Lowell.
Gotcha. And 2 seconds. Want to remind you folks, our guests are linked in the description. We've got more questions. Right now, the page is just loading. Very embarrassing. But thank you guys so much for your questions. This next one coming in from EndoXD, who says, do you not know Einstein's theory of general relativity? Gravity is the curvature of space-time. Saying that's ridiculous is an argument from incredulity.
It's an argument from actual observation of reality.
No,
we
it's
don't
not.
see anything called space and time curving whatsoever.
Yes, we do.
Just demonstrate it.
Except when we watch gravitational lensing happen, which we see all the time.
The
So,
observations that Einstein and Sir Arthur Eddington made in 1917 that confirmed general relativity were observing stars further out from the sun than what they should be because their light was being curved by the sun's gravity. This is how general relativity was confirmed. Yes, we have literally observed the lensing of light due to the result of gravitational fields. We utilize this every day in calculations. This is well accepted amongst all astrophysicists and cosmologists. Anybody denying it straightforwardly just does not understand the mathematics.
Or does not follow
observe
your
as it
religion.
should be, right? Like it's like, oh, it should look like this, but it doesn't. Bro, how do you know what something should look like? The only way it looks like it looks. If you think it should look like something else, that's irrelevant to how it looks, bro. So your whole argument was it should look like this. It doesn't. It looks like it does. Therefore, we're right. Yeah,
So you
that's
don't know how predictions work in science. That's fine.
This next one coming in from, do appreciate your question. This one is from the Crawdaddy029. It says, how does the flat earth explain how distances on the globe earth work out correctly to scale, but the flat earth map does not?
I'll take that one. All of the measured distances are either measured of vertical for elevation or horizontal for distance in between points. They're the only two frames of reference that we have, horizontal and vertical.
Next up,
Navigation on the flat Earth model would be almost impossible.
next up, Matthew.
Well, you can't measure distance across water, though, can you? That's the
Yes,
problem.
you can.
Because it can measure
You can't.
distance
You
across
can,
water.
you can estimate
Yes, you
it
can.
by average
Anyways,
speed.
continue.
Jeez, we're talking about actual measurements, and you just anyway. Let's
No, you're
continue.
not.
No.
Yeah, I
Anyway.
was in the
But
Navy.
talk
You can
about
definitely
actual-
measure your distance across
You can't
water.
use an odometer in the water because you've got water currents, you've got all sorts of different things that can affect it. You can work out average speed and estimate how far you've gone, or knots of miles, which is a rate of knots of a rope leaving the boat. to tell
Nautical
how
miles?
speed you're going. Knots, because it's knots
Nautical
times
miles?
per rope, and that will tell you speed by how fast the rope comes out the back of the boat before you have to wind it back in and start again. Yeah, nautical miles are done by latitude as opposed to real miles, which are done over land.
Oh my God.
Based on a globe.
Let's hear from Paul.
To the globe Earth.
Based on using circular geometry around the center point to use for navigation. You've used latitude lines in ever-increasing circles around the middle point, which naturally then a nautical mile gets bigger and bigger the further outwards you go.
Let's
That's
give,
true.
because we
That's true.
haven't heard a ton from Paul. Paul, what were your thoughts on that? And then we're going to jump to the next question.
I have no idea what he was talking about on the last bit. But yes, you can measure distance over water. Of course you can.
Next up, Matthew Steele says, why has no flat earther ever taken just a single video from the edge of the earth?
Because
That's a ridiculous question because there is no edge of the earth. We believe it's infinite. It goes forever. But the limits of where we can reach is Antarctica, and there are thousands of videos of Antarctica showing a massive ice wall surrounding us.
Juicy.
It's
Mark
not wrong.
Reed, thank you for your
Unbelievable.
question, says, so if we set up a vacuum chamber, Ross, and drop objects, they still drop to the floor at the same speed. Why would that happen?
because the vacuum is the absolute lack of resistance. Whereas, if you dropped a feather in air, a feather has some amount of air resistance. So that's why it gets resisted on its way down. Whereas if you drop
why does it fall down and not
but
go
why
up?
do they fall down at the same speed?
Exactly. Why does it go down and not up?
They both lack resistance from the medium they're in.
Yeah, but why do they fall down at the same speed?
Well, they stop when they hit the floor.
Without the resistance, what's dictating they fall down at the same speed? Could it be Newton's universal gravitational constant?
You can call it whatever you like, but it's still the lack of resistance, an absolute lack of resistance.
Which is defined by what?
It falls by the fact of having mass in a place that has no mass to resist.
In space-time? Yeah, curvature. Thank you. Yep.
No, in a vacuum. Nothing to do with space-time or any curvature. It just falls straight down.
Yeah, but why does it go down? If it's to do with density and you've taken everything out of the chamber apart from the object, why does the object fall down and not go up? How does it go?
Question.
The resistance force always comes from beneath. That's universally being known.
How do we determine that? What experiments determine that? What mathematics defines it?
We don't need mathematics. You just need logical observation.
Yes,
look that everything comes to rest when something of sufficient density resists it from falling any further.
How do you define your observations if you're not using mathematics? Do you realize how dependent physics is on math?
Relative density, mate. Like relative density.
Yeah, but how do you mathematically define that?
Is sufficiently, well, you can measure it by how much volume it takes up and how
what's
much
the equation?
weight. You really need to do it mathematically, but the mathematics is irrelevant to the reality of what's actually happening.
Would you put it on a vertical scale?
Wait, you guys are saying mathematics is irrelevant in your physics. I mean, I'm not surprised by that, but if you understand what physics is, you'll know why mathematics is so important.
Mathematical explanation for it. The mathematical explanation is irrelevant to why it does it. The mathematical explanation just explains what happens and the amount it happens, but it doesn't say why it happens is because there's no resistance beneath it to prevent it from happening.
Yeah, so why does it fall down and not up?
It's a vertical change, isn't it?
So why is it
vertically? That's your geometry. That's your mathematics.
Why is it vertical in one direction but not the other? Why is it going one direction but not the other?
Vertical is up and down, isn't it?
Yes, but so why does it go down and not up?
Because it's not a gas and it's not lighter than the
okay, yeah, but we pulled all the gas out.
Pumped all the gas out.
Why does it go down?
I appreciate your guys' gusto. Just that we have more questions. Sleepy Dan says, my glass of ice doesn't get heavier as it melts into a more dense liquid. Relative density is bunk and easily proven wrong.
Well, that's ridiculous as well, because when the ice freezes, it expands. So it takes up more space, which is why it floats in water. But as it melts and becomes back to the liquid state of water, it's still water. It doesn't increase in weight. It's still the exact same amount of water it began with.
Next up, the Crawdaddy 029. This is a two-parter. He says, that's not Ocean's razor, but it's weird. I think they must have meant Occam's. That's not Occam's razor, but it's weird for you to say the simplest answer is the most likely correct. What's more likely? That there is a major world conspiracy? A project manager's nightmare of people keeping the flat earth a secret, or that the world is just a sphere?
Well, the sphere is the manufactured thing, which we're all brought up from childhood to believe. So you've got no reason to disbelieve the adults who taught you as you grew up. It's only as you grow up and start to think for yourself that you start to question the dominant paradigm of what we're told is reality. As soon as you realize, hang on a second, it takes many of us many years before we start to question what we're told to believe in. We think we live on a ball. Of course we believe it because all authorities say so. But all of these authorities have been indoctrinated with the same stuff from their childhood as well. They've got no reason to question it. They never did. And if they did, they would become the laughing stock of their school or their college, whatever, and they get laughed out of society. They get treated as a pariah, as flat earthers often do. And so most people just go along to get along. They don't want to rock the boat. They want to keep their cruisy jobs or whatever it is, their happy income. Most politicians, they never considered it one way or the other. They just think, of course it's a globe because that's what everybody believes. Everybody wants to be popular and, for what, to say the popular thing. You don't want to go against the grain. You just simply want to.
Next.
So this lie's been going for 2,000 years.
It hasn't.
Yes, it has.
Yes, it has.
You've been told thought it has. It's only been going for like 50 years, really.
Shut
Like this
up.
debate is
So
too late.
100 years ago, they didn't know that the Earth was a globe. So you're saying 100 years ago, they didn't know the Earth was a globe.
The New York Times in the early 1900s of the flat Earth with the ice wall around.
Do you think that the globe Earth has only existed for the last 50 years?
How tall is the ice wall?
Who cares about how tall it is? It varies.
Well, I mean, if it exists, obviously we've been there by now.
The question
like,
is,
we've
how long has this
measured it.
been going for? The debate has been raging since the beginning of time, really.
So
And
you
most
don't know.
people thought it to
You
be
just said it's
flat.
been only going on for 50 years.
But since Hollywood took
Yeah,
off,
there hasn't
and
been a
Universal
debate.
Studios start showing this image of the globe, and that same image is the same one that NASA showed us in the 70s or late 60s, whenever they took their first blue marble image. It matches the one that the Universal Studios was showing us since 1927. So they've known about
Let's
They-
let's
they
be clear about
basically-
one quick thing though. There is not a debate. There hasn't been a debate for over 2,000 years.
No, that's wrong.
What
That's
there
wrong.
is
What you're
fun little
told.
entertainment where people
You know,
who clearly
without-
don't actually know the actual science or anything that they would need to criticize anything about science come on and pretend that they know things that are flatly contradicted by obvious observations. That's what we have here. This is theater. This isn't a debate. There hasn't been a debate for over 2,000 years.
I'll give you a
Like I
really
said at the
And
beginning,
I'm not
really
actually convinced that you
short-
believe it's flat. I'm not convinced you believe it's flat.
We'll give you a really short response, Ross, because I don't want to gang up on you, but then we got to go to the next one.
I'm just saying that nobody was there 2,000 years ago to know whether or not there was a debate raging. We know there
Except
was a
the
debate.
people that were there.
All the
years
people
ago.
writing histories.
All right. Oh.
And so we know that people were debating it. You got your Henry Rowbothams and so forth who were doing experiments that proving it's flat. And so this debate was raging. And the only reason it was ever considered settled was because NASA started faking images through
Short
a
and
round window of a high altitude vehicle in the late 60s and said, this is a picture of Earth from space.
Must
That was when it was
move on.
settled that we live on a blue
Must-
ball in space.
Mikey Riot says, James, you got to host Leo again. He's brilliant.
He's good.
That's nice. Your mom's in the chat, Leo. Okay. but seriously, I want to let you know Leo and all of our guests are linked to the description. So, folks, do encourage you to check them out. We appreciate our guests. We're really glad to have them here. And so, Mr. Wilford, thanks for your question, says, why do you profit-based airlines will plot their flight paths in fuel inefficient ways, like they're accounting for the curvature of the Earth? Why waste fuel on millions of flights versus just flying in a straight line? In other
Very
words,
good question.
why do they, why do profit-based airlines fly as if there is curvature in the Earth when they could save a heck of a lot of money by not flying that way?
Exactly.
Just plot it on the flat Earth map and you'll see they're going in the straightest line possible. They're not matching the globe whatsoever.
Yeah, but the lines are curved.
Yeah, when you
That's
plot
how they
any
died on the-
commercial
When
flight,
you put it on a navigational chart, it's curved.
Yeah, they're curved. They're geodesics.
and I mean,
Yes,
this isn't even
screen.
hard to do. You can watch in many current
Straight
planes.
line.
You can watch where you are on a map of the Earth that is usually some kind of like Mercator-like projection, and you can watch your flight path curve. And you can also look out the window and notice that what you see out the window matches what you should be seeing based on your flight path, and it still works over land. Granted, if it were all over water, it would be hard to check, but it all lines up. So really all you need to do to prove that the Earth is a globe is take a flight of any great distance over
And watch
land.
the television screen in front of you.
No,
You
watch
look
that
out the
and
window,
then
you'll
also
see
look
the horizon.
outside and then double check the map. You can also even have people stationed on the ground if you want to coordinate to spot your actual plane because there are plane tracking apps.
Yeah,
And you can
look
say,
out the
hey, look,
window.
that's actually the plane.
I think we should let the pilot
Look out
Oh,
the
yeah,
window
sorry.
and notice-
give a comment.
We do
Paul.
have a pilot.
Yeah,
Notice
Paul,
how you
let us know
never
what's
go
up.
upside down.
Yeah, on
when you're
long distance flights, if you plot it on a flat map, you will put a curve into it to account for the curvature of the Earth. On a short distance that I fly, I don't bother with that because I'm only doing 60 miles. But if any great distance, you include the curve for exactly what was said in the question to save on fuel and to save on distance.
Yes.
So if you fly like 2,000 miles, you're going to start here and then you're going to be directly under yourself.
Yes.
Oh, because the Earth is, well, Earth is much bigger than 2,000 miles in circumference.
Yeah,
So,
so
no,
how many miles do you have to go before you're completely under yourself?
half the circumference.
Yeah.
And you feel that orientation change, right? Of course.
No.
No,
Why
why
would you feel the
So it's
orientation
almost,
change
would
when
you
you've
say
got
it's
gravity?
almost like you're flying over orientation wise, you never feel so it's almost like you're just going
no,
flat.
because it's the same center
That's how
of
it
gravity.
feels. I'm just saying how it feels. It
Yeah.
feels like you're going flat. Yeah, it feels like
Yeah, because the center of gravity
That's a
does not
concession. I'll
change.
take it.
Can I just ask?
Because you are horizontal to the globe.
Horizontal. Okay.
Yeah,
Can I- one question
you're always horizontal with the center of gravity.
Is the
so you're not
amount
gonna-
of air curvature altitude dependent?
What do you mean?
Is the what?
What do you
the
mean by air
amount of curvature
in the atmosphere?
Yeah, is that
Well-
altitude dependent?
Yeah, I mean, the higher up you go, the larger the diameter is going to be.
What about the spin of the Earth beneath you? How do you account for that if it goes twice the speed of the aeroplane?
Because the atmosphere is traveling with the globe at the same time.
Exactly.
It's all moving at the same time.
Remember your whole thing
Okay.
about how you can't measure
Stationary
distance because of
in the
relative
air.
motion of the Earth and the. So Ross,
Pick that
Stationary
up.
is going
Ross-
1,000 miles per hour.
No.
Ross,
The
the problem that
atmosphere
you're having
doesn't
here-
turn at 1,000 miles per hour. It turns relative to the
But
speed given your position on the surface of the Earth. Because
Okay,
the closer to the poles you go from the equator, the lower the surface velocity of the rotation of the Earth is. This is why when we talk about the rotation of the Earth, the most accurate measurement is to say that it rotates at a rate of 3 degrees per hour, 15 degrees per hour.
Well, what is wind?
Wind is motion of
wind
the
is
air
local
relative to the
motion.
surface.
Yeah, it's
Yeah.
local motion of the wind relative to the surface
So
in that
the
area
local
that is
motion
generally
overcomes
driven by
the
differences in pressure, by
Right.
pressure
What
gradients
is in the
and
atmosphere,
energy
really?
from the sun.
Yes, caused by the warm air currents.
Yeah.
But you just said the whole atmosphere is moving with the Earth, and yet
Yeah.
The atmosphere
As a whole,
is
on average,
moving
yes.
in relation to
Wait,
the
hold
Earth,
on,
but
Ross.
inside that, it's fluid.
Ross, have you ever been looking at a river or a creek flowing and you'll notice that there are places where the river might start to circle or swirl or anything? There's backward motion in that river, but the river is still generally flowing in one direction. Same basic principle. The atmosphere of the Earth is very turbulent. It generally moves with the Earth, but there are points in it and areas in it where it's moving, it's still rotating with the Earth, but that atmosphere is moving relative to the gradients in the pressure.
The ground beneath the river isn't moving with the river. You know, the
What's
river is
that?
moving independent. The river is moving independent of the ground. The ground isn't moving with the
I
river.
wasn't talking about the ground.
I want to give Leo a chance to respond,
Well,
and then we got to go to the next one.
The ground is moving with the atmosphere. And so you're comparing the atmosphere to a river above a stationary ground and
He
saying
was
that the
using
ground...
the river to explain what was going on. It wasn't
Yeah.
comparing the two together. He was using the river to explain
Yeah.
what you
I was
can
using
see.
the concept of a river flowing, and then if you put a rock
But
in the middle of the
water is
river,
flowing.
it might
on,
cause
hold
some
on.
swirling to occur, but the river is still moving in the same general direction. It's the same thing with
The
our
river
atmosphere.
isn't moving,
There's
mate. The river
there's
is
One sec.
turbulence.
Well, let's
There's
let Leo finish. I
turbulence.
promise we'll come right back to you, Ross.
just like the ground is stationary.
I'm not talking about the ground is not relevant here.
It is
what I'm
relevant.
talking, what I'm not the example I gave. I don't know how often you floated a river, but I've done it a lot. There's rocks and differences and everything like that that can cause the river, although it's flowing in one direction, there can be points where it swirls or points where it flows backward and then comes back around. That's called turbulence. We have that in Earth's atmosphere, despite the fact that it rotates, because the friction of the surface of the Earth on the atmosphere over the billions of years that the Earth has been rotating will begin to drag on the atmosphere and cause the atmosphere to rotate with it.
You have to bring in the billions of years, don't you, to say that this is why the atmosphere moves with the
we
Earth.
we know that the Earth has existed for billions of years. So I mean,
the water is flowing through the river banks, and so the wind is moving independent of the Earth. It's not moving with the Earth. The Earth
Yes, it
is like the river banks. The wind is moving independently. Because if you're saying that the
we've been on
wind
this
is
one a long
also
time.
moving at 1,000 miles
I
per
hate to
hour with
interrupt.
the Earth,
Can I just get a quick one in here, Ross, please? Leo, would that make the cause the air's curvature? Would that mean the curvature of the water level would also be elevation dependent?
I want to let Leo answer, then we have to go to the next question.
what I mean, if you're talking about the relative angle on a sphere, when you move from the center out to the full circumference, the angle of two lines defining those points will increase. So you could say that theta, your angle, will increase. If that's what you mean, then yes.
No,
If
just
not,
the
we'd have to go
curvature,
further.
the
into
amount
it.
of curvature of the water
We must
level.
go to the next one. I hate to do that, but the Crawdaddy029 says, how does the flat earther side explain that when you go south and get to Antarctica and turn left to follow it, you make all right turns around it. I'm the only person confused by
I would
that.
like to know if he's done that. Has he done that traveling trip to confirm that's what happens, or is he just going on his model in his head?
Next up, Magellan says, Flat Earthers, why does celestial navigation require spherical trigonometry to get a position fix?
It doesn't.
Yes, it does.
Triangulation has to be done through a triangle. If you don't use a triangle, you can't triangulate.
So you don't know what spherical geometry is.
You have
or
that
spherical
azimuthal
trigonometry.
angle.
Leo, that's been pretty clear for a
celestial
while.
navigation.
I mean, it has.
That's not
Next up.
celestial navigation. That's your
Magellan.
tower navigation via GPS. You got 2 or more towers, you can pinpoint your position because the towers are fixed. While you're moving, it will tell you where you are.
Paul, is this true?
GPS are on towers. So explain how you can get GPS signal then in the middle of the ocean.
Exactly.
It's radio signals. Radio signals propagate for hundreds, if not thousands of miles.
Man, if
I've
only,
had a
if only
that-
radar horizons weren't a thing, so many lives could have been saved in World War II because it would have been impossible to ambush fleets on the ocean, and yet
Yeah.
it
Tell
still
me how somebody
happens.
was able to talk to Hawaii with a normal ham radio, even though he had illegal crystals in it, which gave him channels that you're not supposed to have here in Australia. He was able
Yeah,
to talk
that'd be
to
the radios that you bounce off the atmosphere to go across the curve.
Yeah.
I used to do that myself.
Uh-huh.
You must
It's
jump
funny how you
back.
can't always do that because it's dependent on atmospheric
Yeah,
conditions.
exactly. It's dependent on what the atmosphere
You
is
can't
doing at
bounce
the
off a
time.
vacuum.
You get the
but you can bounce off a
ionosphere,
vacuum.
which you can bounce the radio signal off it so you can go a further
But an
distance. I used to do it 20
ionosphere
years
is
ago.
ever decreasing density of anything. There's more nothingness than anything. Because
No,
that's how your gravity works in the first place. The stronger the gravity pull is, then the more dense the air gets lower down. Hence, we have the air pressure gradient according to gravity, whereas we just call it the volume of it and the amount of it pressing down on you. But if you're getting up to the ionosphere, you're talking about nothing. But if it was an actual firmament, you could actually bounce something off it like radio waves.
You do bounce
Cleary.
stuff off the ionosphere. That's
So
exactly what you
Ross
do with
doesn't know
radio
how
waves.
electromagnetic radiation
Cleary
works.
says, thanks for your question. Can Bev explain how right line geometry defines the Euclidean 3 space of our world?
Yeah, easily. Thanks, Clary. Yeah, the right lines are the 2 right lines that make a right angle. They are a horizontal plane and a vertical. Those 2 reference frames are the reference frames that we use in reality all the time. We use a tool called a level to establish a horizontal, and then we measure vertical change. That vertical change from that horizontal is elevation change. I mean, that's how it works in reality.
Gotcha. Next up, this
Bev,
one
is that
comes from-
horizontal?
I can't see.
I can't. Oh, there it is.
Now we can.
What?
The line on the
Line.
top of the circle I've done, is that horizontal?
Put a level on it. Yeah.
Yeah. Is that horizontal?
Nah, that looks
It is if you're on the
vertical.
globe.
It's not.
Yeah. It is if the center of gravity is the center
The,
of the
Exactly.
the
Earth.
horizontals don't turn into verticals. They just don't.
You're
It's
right, they don't.
horizontal to the globe.
We must jump into
Oh,
the
no.
next one. Matthew Steele says, Leo, are you familiar with cat earth theory? If the earth were flat, cats would push everything off of it.
Yeah.
That's funny. Yes,
Yeah.
I am familiar with that.
By
It's
the
funny
way,
that cats don't like water, so they're not going to swim all the way to Antarctica. And it's a
I
little
don't
bit
know
too
about
cold. Cats would become icicles in no time at all.
anyway, I was going to also say, Leo, I'm sincerely sorry I was so rude to you earlier. I feel seriously.
You were rude to me?
I was, yes, and I'm sorry for that. So I do apologize for getting a little snippy, and I was a little.
Oh, it's all good.
But yeah,
I don't
so-
remember that, but it's okay.
Thanks for your short memory. So thank you. And but yes, we do appreciate our guest folks, and so if I am ever a little bit cranky as a moderator, forgive me. We do appreciate them a lot, and they are linked in the description. And also, Dapper Dino has an after show, which is pinned to the top of the chat as well.
And I will be sending the link to join that in the same email chain that we're all in. So any of the panel members are able to, if they want to. I realize it's very late in some places, so I get it if you might not want to, but it will be an option.
And the
How about
Crawdaddy,
12 already? Midday.
the Crawdaddy 029 says, how do flat earthers explain that there are flat earthers all around the globe? Okay. That meme. I'm
Yeah, they need to do a
curious
global tour.
you guys have, even, I mean, Flat Earth Aussie, Kent Hovind, he loves this meme. I don't know if you know this, but Kent Hovind, he's not a flat earther, and he loves showing this meme of apparently a flat earther who posted on Facebook, join the Flat Earth Club, but we've got clubs all around the globe.
James, that's who you need to get to be the globe defender on your next Flat Earth Globe debate is Kent Hovind.
We've asked him.
Kent Hovind versus Nathan Thompson.
We've asked for it
that'd be a
many
classic.
times, but he won't do it. I mean, I'll ask again, but thank you for your question. This one coming in from the Crawdaddy029 says, why are flat earthers so wrong at what science concludes? Let's see. We haven't heard from the hand. What are your thoughts? Agree, disagree?
Science is the new religion, right? It's like we all see the same effect, and then science will try and get more from it, right? They'll tell you the why. So I can stand with a scientist and see the effect that he sees. Then he's going to be like, well, before we saw what we saw, I made a hypothesis. So now I know more about what we saw than you, and I can tell you why it happened. And I'm going to be like, well, if you saw the same thing I did, you can tell me why it happened, then I should be able to say why it happened. So,
can I ask one really quick question to that?
I'll listen
really
to
quick.
the scientists.
Do you know, the difference between a hypothesis and a theory?
There's no difference. They're both mental.
Okay, yeah, that answers everything I needed.
Yeah.
We can continue.
Technicalities, Menda.
I like Flat Earth Rossi or Aussie. Are you having a brewski out there? It looks comfy, buddy.
Bloody oath, mate.
An excellent question.
Time for another.
Sigma Any says, for the flat earthers, what would happen if we clip the string that tethers the sun to the great central axis? You don't believe that, do you?
It'd fly off into space.
Okay. Brian Williamson says, I'll fight anybody here. Thank you, Brian. Did I miss any? Let me just check if there are any last ones. We do have another one. This one comes in from Mr. Wilford. Thanks for your question. Said, why did we can't say this word on stream, NAZIS.
Oh, the National Socialists?
That's right. Have to account for the curve of the Earth when using the Gustav railway gun. Right the hand.
Bent space.
I mean, you're asking. So because the Nazis might have used the gun.
Oh, there he goes.
Use the word. That's all right.
What
Go
Nazis?
ahead. Just answer the question.
Because Nazis are liars, bro. You know, they're Nazis. They'll lie about anything to get what they want, which is power. And
so they were lying to each other about how to aim their gun so that they could lose the war so they could get power.
Did they win the
Checks
war?
out.
Did they win?
That checks out.
Well,
No, is it because they were lying to themselves about how to fire their guns? Is that really the claim you're going with? Is it the Germans hated everything, including themselves, so much that they lied to themselves about how to aim a gun from a train?
What I'm saying is they thought the Earth was a sphere. They lost the war because they couldn't aim right.
Oh, wow. So all the Allied artillerymen were not taking it into account. Is that what we're going with?
They would have won the war if they would have taken this into account, and they wouldn't have been missing, and they wouldn't have lost. So maybe if they knew the Earth was flat and they didn't account for curvature, they would have had more direct hits.
Well, in the inevitable flat versus globe Earth civil war, good luck with the aiming tables for your artillery, guys.
Yes.
Next
The
up.
Germans actually found the escape route underneath Antarctica with their U-boats, and so after they had won, they decided to just concede escape and leave it to the evil allies who think they won when they actually lost.
Right.
I said too much.
Right.
Next up, this one coming in from Chris says, no, radio is bounced off the firmament. Duh.
Oh, that's a good point.
No,
Leo, we just lost. Let's pack it up.
Yeah.
Yeah.
Oh, shit.
No,
I don't know what to say to that.
Brian,
But
Williams.
on a serious note, learn how electromagnetic radiation works.
Brian
Learn how
Williams.
to make that a great version, right? It's okay.
Okay, well, Brian Williamson says, should I buy Bitcoin, gentlemen?
No.
I'm going to go ahead and say, if you have money that you don't actually really need right now, then sure, fine, spend some of it on Bitcoin. But never put more into something as volatile as Bitcoin than you can afford to lose. Treat it like a casino with, granted, slightly better, well, a lot better odds than most casinos, but still treat it like you're going to the casino. If you have an extra $20 to spare, sure, put it in Bitcoin. I don't care.
Silver has went from $18 an ounce to $28 an ounce.
Juicy. And Ozian says, Kal-El is God, and he told me the world was a cat and not flat. Thanks, everyone. Thank you, Ozian.
See, he told me it was a dodecahedron, so now I think we have a schism coming.
Uh-oh.
So
I'm going catnip to take over the world.
it's always fun, folks, and do want to remind you, yes, we appreciate our guests, and they're linked in the description. You can hear plenty more where all of these answers came from. We do want to encourage you to check out their links below. And so thank you, all of our guests. It's been a true pleasure to have you, and especially thank you, Paul, for staying up super late with us. Paul, what time is it there?
Oh my
It
goodness,
is 20 to 4 in the morning, but this is one of the best and maddest things I've taken part in.
It's been
Cheers to you, Paul. That is some dedication
Yeah,
to this. I probably
sure.
wouldn't be doing it if it were 4 in the morning.
It's all right, because I'm going to go downstairs in a minute. I get myself a Jack Daniels. I'm going to log on to your after show.
Well, thank you very much. That link will be forthcoming right after the we go off here. So
Okay, no worries.
So thank you, guys. It's been a true pleasure. Leo, Paul, Dapper, Right the Hand, as well as Bev and Ross, thank you for hanging out with us. It's been a true pleasure.
Always enjoyable,
Had a
James.
good
Thanks for
time.
having us.
And thanks
Yeah,
everybody
loved
for
it.
it's been this has been a really fun one, you guys. I love this format. This has just been really high energy, and so thank you guys. It was honestly a blast. And also want to let you know, folks, I'll be back in just a minute with a post-credit scene on upcoming debates. We do have one tomorrow night. You won't want to miss it. We have a lot of other ones coming up that are juicy. So stick around for that. I'll be right back. Thanks, everybody. Keep sifting out the reasonable from the unreasonable. Ladies and gentlemen, that was a blast. Thank you guys so much. I really enjoyed that. You guys, that was seriously really fun. Thanks for hanging out with us at Modern Day Debate. We appreciate you guys. Thanks so much. I love getting to say hello and just hang out with you guys at the end here. This is always fun for me. So saying hello to you in chat. Planet X, glad you made it. Fernando, we were glad you were here. Freddie Fastfinger, thanks for coming by, who says invest in gold. It's the only true currency. Thanks for coming by. And Third Finger from the right, good to see you again. Megan Satanis, good to see you again. Apricot Sloth, glad you're back. What? Glad you're back. And Kemet, good to see you again. Mark Reed, glad you made it. Thanks for being with us. And Mind Onion, thanks for coming by again. Long-time viewer, Mind Onion, you've been hanging out here a long time. It's like, were you all the way back when we used to be called Modern Day Hysteria? But yeah, Spretchen, C. Globe Tardia, thank you for hanging out with us. We're glad you're here. And Nate Cross, glad you're here. Fox Sushi, hello, my friend. Joker's Wild, good to see you again. Kirk Welson, thanks for coming by. Trolling for Truth, glad you're here. John Pelosi, glad you're back, friend. Albert Bitcoin, Robert Page, and John Guzidik, thank you for being with us. We are glad you came by. Sleepy Dan, thanks for being here. Marion Gran Burheim, good to have you. And Patrick Vaughn, thanks for coming by. Hey, you, glad you came by. Joe the Toe, good to see you again, man. General Balzac, good to see you again. Hoping to get you on here in maybe the next several weeks for a possible tag team debate on capitalism versus socialism. Should be fun. And Mariko Mudd, glad you're here. Helioskeptic, thanks for coming by. Said it went better than I thought. Oh, I'm glad to hear that. Lambie, I was awesome. I loved it. It was a great event. Lambie, good to see you. BV, thanks for coming by. Fox Sushi, John W, thanks for being with us. And let's see here. I'm catching up with chat. Thank you guys. It's always fun though. Known Universe, we're glad you're here. And Billy Blue Heron, good to see you again. Says, personally, I love this channel. I'm sorry for trolling the comment section so often, but seriously, I think the elevated debates are the best. Flat Earth, not so much. Well, we're glad you're here. And Human Girl, good to see you. And Question the Answers, glad you're here. Said James, thank you for an awesome show, my brother. Thank you. And man, we see Ross Thatcher in the live chat. We can't thank the guests enough. They're the lifeblood of the channel, and they make it fun. And so thanks for coming to party with us. Dapper Dino, Leo, and Paul, as well as Ross, Bev, and Right the Hand. It was a blast. And Mike W, 777-220 says, thanks for the forum. My pleasure, Mike. Thanks for being with us. Bond says, howdy, James. Good to see you, my dear friend. Hope you're well. And then, I love getting your feedback, folks. Nomad Teacher says, hi, James. How are you? I hope you're doing well. Thanks for being with us, Nomad Teacher. And then Third Finger Room the Right says, don't forget about Twitch. Oh, you're right. Sorry, Twitch fam. Lucille. Is it pronounced Lucille? Thank you for being with us. Ozzy, and thanks for your Twitch subscriptions, by the way. Seriously, thanks so much. And Tapatzel, thanks for making those emotes. They look great in the chat. Move 37, thanks. I agree. Much love to you, my friend. And yeah, those emotes look legit. I love them. So Mystic Warrior 1137, thanks for coming by. Says, Flat Earth debates are always the best. Great show, James. Thanks so much. That means a lot. I'm glad you liked it. Kai Reason says, racists are plagued with the same ego struggles as flat earthers. Sorry, I didn't mean to take a side. I try not to read those, but I just sometimes I read something without like processing what it's actually saying. So, but yes, B Badass says, sorry, I never got to chat much, but I always listen. My job is caretaking an elderly client. Oh, that's cool. Well, that's a noble job. That's really cool. So good for you. And Billy Wool, glad you're here. And yeah, you guys, I am excited though that the funny thing is the podcast, the Flat Earth debates, when we upload those onto podcast, they do really well. So it's like, it's funny that the people who listen to the Modern Day Debate podcast, they also love Flat Earth debates. And that makes sense because most of the people that listen to our podcast learned about it through the YouTube channel, right? So like I usually mention, which I will mention, you guys, we uploaded a really good one today. It was Dr. Josh and Surus Skeptic. They debated praise, and I'm trying to remember who else it was, but two Christians on biblical slavery in the Old Testament. I just uploaded that to the podcast this morning. Folks, you don't want to miss that one. It was a really fun one. I was there that night. I got to moderate it. It was a blast. And so I would encourage you folks, it's like if you're already on your phone, well, how convenient is that? You could pull up your favorite podcast app right now and you can find Modern Day Debate. I guarantee it. I've worked really hard to get us on virtually every app there is, like Apple Podcasts. What are the other ones? Let me think. 2 seconds here. I'm going to pull this up because I love this little dealio. Oh, wait, I'm gone. Here, let me see. I know where it is. Hold on. There it is. Oh, here we go. Yeah. Stoked. You guys, as we are a neutral platform hosting debates on science, religion, and politics, and pretty much every topic you can think of. If you haven't yet, hit that subscribe button, folks, as we are really excited about upcoming debates, which I told you I'd tell you about, and I'm going to right now. Tomorrow, is anti-theism rational? It's going to be Amy and Raging Atheist against Sal and John Maddox. So that should be a juicy one. And here they are. Here are those podcasts. So right over here, check us out in your favorite podcast app. Stitcher, we're on Apple Podcasts, we're on iTunes, Spotify, Podcast Addict, which that's the one I actually use. I use Podcast Addict. That's just the first one I ever used, and I stuck with it. But yeah, we're also on Google Podcasts. I'm curious. Well, let me know, chat. What podcast do you guys mostly use? I asked this once before, but I'm trying to remember. Because we want to be sure that we're on your favorite podcast. And so if we somehow aren't, let me know, because we really do try to work hard. And so I've been so encouraged, though. Like I said, people are like, oh, it's great for when I'm cleaning. I'm like, doing workouts, I'm taking a walk. Sometimes people listen to it on their commute to work. And so that's encouraging. And it's nice, like long form content. One nice thing about it is you don't have to like constantly click down to play the next video or the next song or whatever, because it's long, so it'll last you an hour and a half before you have to click on the screen again. But anyway, Albert Bitcoin, good to see you. And Brenda, good to see you again, as well as Question the Answers. Got to say hello. Thanks for being with us. General Balzac says, be glad to do so. Partner seems up and down on it. I'll hit him up again tonight. Good to know that. Crawdaddy029 says, you didn't read my 2-part question. Oh, I'm 99% sure that I did. I'm not joking. I really do remember reading that one, because I remember I said it. I was like, this is a 2-parter. So unless you had two-parters, but I'm telling you, I really did read it. Let me know if you did, but I only saw one that said like part 1, and then you wrote it out, and then the next super chat it said part 2, and then it had the remainder of the question. Unless did I not read the second part? And maybe that was the mistake. I don't know. Let me know. But let's see here. Brooke Chavez, thanks for your support. Said thank you for another amazing debate. It was amazing. And but yeah, let's see here. The other, let's see. Oh, okay. So Brian Williamson says Apple Podcast. Sephrin listens to more than one. Says Spotify and iTunes equally. Oh, that's interesting. And let's see. But yeah, I am super excited, you guys, as the podcast it's exciting that it's, like I said, when I first started it, I was like, are people going to use this? And I was like, am I wasting my time? And oh baby, it's grown. Like people are really finding us on their favorite podcast app. And if you want to support the channel, I would say, hey, rating us. If you give us a rating on your favorite podcast app, that helps too. And so we do appreciate that. So let's see. Third finger from the right says, don't forget about Twitch. Oh, you're right. Let me jump back over there again. But yeah, Ozian, thanks again for all of your support. And Tapatzel again, those dank emotes in Twitch. If you guys haven't seen it, I do want to share that with you. Let me put the Twitch, our Twitch. So I'm putting the link to our Twitch, you guys. If you are listening via YouTube, I'm putting that in the chat right now. And then I will, what's the word I'm looking for? I will pin it to the top of the chat, so that way if you have not checked out our Twitch yet, you can. And also want to remind you, if you use an Amazon Prime subscription for Twitch, which we appreciate if you do that, thanks for doing that. I want to remind you that you have to, I think it's like every 30 days, Twitch will ask you to reset it. You'll have to go back in and reset it. And so thanks again if you're willing to do that for us. We appreciate that support. And it's, yeah, if you have Amazon Prime, a lot of people don't know, you have a free Twitch subscription that you can use. You can give to any streamer you want. And so we do appreciate when people do that for us. It helps a lot. And so thank you guys. And then let's see, the Crawdaddy029 says you didn't, oh, sorry, I read that one. But yeah, let's see here. That's funny. Amazing. Matterform, thanks for being with us. This question, I would like to collab to make some motion graphic versus VS intros. What is the best way to get a hold of you guys? Thanks, Matterform. I appreciate that. That's really nice of you. Matterform, I'm going to, right now, I'm tagging you in the live chat with my email, which is moderndaydebate@gmail.com. So thank you for being willing to help. And let's see. Bal Diablo, thanks for being with us. And S. Ibni Henry Abdullah, thanks for being with us. G Cash, good to see you. Glad you're here. And I'm almost caught up on the chat. B Bada says, I tried the email on your YouTube channel, but it says it doesn't exist. That's wrong. It definitely exists. Trust me. You might, I think if you did try it, I know it's the right one because I get emails from it. So it might just have been a typo. Sagna Metal Windeer, thanks for being with us. We're glad you're here. Rezo out of Gore says, great debate today. Do you think the uptick in audience for flat earth debates is something akin to the old and the circus? That's funny. You're funny. It's always fun. We do enjoy a good flat earth debate. We've had a lot of them. I think we're going to take a short break where it might be I don't know, maybe a week, at least a week until we have another flat earth debate, maybe even 2. I mean, we might go crazy. We love doing them. It's a lot of fun. Steve Coates says, thanks again for creating this channel. Thanks, Steve, for your encouragement. That seriously means a lot. I really do appreciate it. So thanks so much for your support, because I do love it. It's fun. And that's our whole gig, is we've always said, hey, we want to really encourage people and just say, hey, no matter what position you have, we want to be open to letting everybody make their case. And hopefully we do it in a way that's fair to everybody. And so John Skzdilic says, thanks, James. And then B Badass says, would you consider nutrition and fitness a scientific debate? I would love to see people debate different health related topics. I'm kind of a health nut. We're open to it, especially on related to veganism. That would be, it would ideally be like bigger, I can't remember his name. I think it's like Lane. But if it was like Lane and Vegan Gains, like that would be a cool debate. Crawdaddy029 says, it's possible I just didn't hear you read it. That might be, I don't know. Let me know. If I missed it, I'm really sorry, and shoot me an email and I can Venmo it back. But I think I got it. I read them out of order though. I do remember that, Crawdaddy, because sometimes the page doesn't load and I just read whatever super chat shows on the screen. So that might have been why you missed it too. So Chris Gammon says, hey James, I had to come and go tonight, but I really enjoyed the debate. Good to see you, Chris. Thanks for coming by, buddy. And Chris, I'm trying to remember. You're in Texas, right? Is it the Dallas area? Do I remember right? I know you're in a warm southern climate. It's either Texas or Florida, but I think it's Texas, and that's why I envy you. I used to live in Texas, and it was great. It was very warm. The winters were tremendous. You guys believe me. But yeah, thank you guys so much. What says Modern Day Flat Earth Awakening? And Wayne Templar, good to see you again. It's been a while, man. But yeah, I am excited about the future, and so thank you guys so much for your support. We are excited about the future. Oh, let me tell you guys about other debates. This is not for sure. I've still got to ask. I've got to confirm it. But we're going to invite Destiny back on for this Sunday. Whether I can get a hold of him on time, that I'm figuring out. But we do enjoy a good old debate on, it'll be capitalism versus Marxism potentially, if we get to host that. And so also though, you guys, I think it's next Monday, we might have Kent Hovind back on. I'm waiting on a secretary. I think she still didn't get back to me today, so I've got to respond. I've got to say, hey, like, did you forget about me? Like, what's going on? But basically, we are hoping to host another debate with Kent Hovind. So that should be a juicy one. You don't want to miss it, folks. And that should be on Monday, and it should be with Maddie. So that should be a cool one. We're excited for it. And still confirming the deets on that. But also, you might be like, well, what other debates, James? Well, Tuesday, we're setting up one that is almost complete with JF versus Socialism Done Left. So that should be a really fun one as well. And for some reason on my YouTube, let me find this, you guys. This is super interesting. Oh, there's the Twitch chat. I can see the Twitch chat. Thank you, Sephirin said I should watch here more often instead of YouTube. Yeah, the Twitch chat is fun. It's easygoing. People are friendly in there. Kai Reason says, I'm in Texas. I'd rather be in Washington personally. Too dry here. Hey, I know what you mean. Are you in, you must be, I'm guessing you're in West Texas. I lived in Lubbock and I loved it. I love the dry heat. Couldn't complain about that. Now I lost the chat. Oh, there it is. Here it is. Thanks for your patience, gang. 2 seconds. But I think Dylan has an epic show, so we're gonna raid his debate, his stream in just a minute, because I think Dylan is live right now. So raid Dylan Burns TV. So slash. A hype train is close. One more person needs to sub, gift, or use bits. That's what Twitch says. What is a hype train? Oh, it actually answers it. It says, a hype train starts when multiple people subscribe, use bits, or gift subscriptions to the community. Once a hype train is underway, the community fills up the hype meter with more subs, gifts, or bits. Everyone who contributes receives one unique emote based on the highest level completed. So, well, that's cool. I don't understand it, but I'm new to this Twitch thing, but we are learning it, and I'm glad that the Twitch has been enjoyable for people. Okay, I'm going to raid. So if you're in the Twitch chat, I want to let you know we are about to raid Dylan Burns' channel. So let's see here. So I am about to jump over there. Dylan Burns has an epic debate tonight. And so it'll have Vosh and the crew. They're debating, and they've got a lot of people over there. So you guys, you don't want to miss it. It's going to be epic. And so I am doing that right now. You ready? Here we go. It's going to be epic, you guys. 8 viewers are ready. 7 viewers are ready. 8 viewers are ready. 9 viewers. Raid right now. So yeah, we're pumped. We hope it's fun over there, as we always enjoy good old Dylan. We get along well with Dylan. I've enjoyed Dylan. And if you guys didn't see last Friday's debate, which Dylan graciously invited us into, it was absolutely awesome. And so we are really excited about that. And so, but yeah, I'm pumped, you guys. And so that debate last Friday was 100% epic. It was really, really fun. And so we enjoyed it. And I hope you did as well if you enjoyed it. And Lyric Edge, thanks for being with us. And let's see. Heat Shield, good to see you. Glad you were here. And so thanks, everybody. I love you guys. Seriously, it's always fun. Human Girl, thanks for those hearts. Always so kind. But yeah, you guys, seriously, we love you guys. Is there anything I can do to make your day better? Let me know. We really do. We hope that this is a fun time here. We hope it's a fun community. And also, yeah, it's like, I hope that it's just like, it's fun, you know? So let me know. General Balzac says, I must have missed that. I actually remember someone making that argument back on the Non-Sec show. Let's see, before the dark times. Before the dark times, for the Empire. I remember. It's crazy. General Balzac says, is James expanding borders? We are expanding borders in a lot of ways. We are trying new stuff. Believe me, guys, it's honestly, we're excited about this summer especially. We're going to try some cool stuff, like in-person debates. We're going to get back into it. I'm excited that I've got my, I'm scheduled to get my first vaccine shot on Monday. And so it's exciting that hopefully in June, maybe even May, yeah, I'm going to push for May. We'll be, out and about, and we'll be hosting debates and all that good stuff. So it's, yeah, it's going to be epic. So we are really excited about that, to do some in-person debates. And those have always been fun in the past. And so I'm excited for it. And yeah, but yeah, I do love you guys. Thanks so much for making this fun. Like, it's honestly, it's always a blast. So thank you, guys. Keep sifting out the reasonable from the unreasonable. We hope you have a great rest of your night. Top Hot 2, thanks for your super chat. Says a hype train is when lots of people on a channel subscribe or give bits in a short time. You can then get special things from Twitch for adding more. Oh, well, that's okay. Gotcha. Well, that's cool. I'm excited that we're close to getting one today. And so someday, that's cool. And so, yeah, we are pumped, though, for the future, you guys. I'm just optimistic, and you guys make me optimistic. You make me excited about the future and just about where everything is going. And so thank you guys for that. Brooke Chavez says, y'all have a wonderful night and hit that like. Yeah, thanks. Totally appreciate it, you guys. Please do hit that like. And I am excited that, yes, we have plenty of flat earth debates on the podcast, though, which is really cool. And so hopefully that's useful. We hope you enjoy it. And yeah, like I said, I would say the debates that do best in terms of like people enjoy them the most or download them the most on the podcast are one, Matt Dillahunty debates always do well. I just put a Matt Dillahunty debate up, I think it was 2 days ago. So that was our most recent debate that we hosted with Matt. And so you don't want to miss that. Like that's a good one too. And so that's the second most recent episode on the podcast that we uploaded. And then, like I said, there's a lot of cool stuff. So Harold, see you in the live chat. Glad you made it, Harold. Hope you're doing well. And so, yeah, I don't know. You guys, I don't want to say goodbye. I just like hanging out here. So I don't know. I'm just going to kind of drink my seltzer water and just kind of maybe just lurk, just read the chat and not say anything. And, John Smith, glad you made it, man. Thanks for coming by. And yeah, I'm excited though. You guys, it's fun. You guys get it. You guys make me laugh. Let me pull up. I'm going to try to find the calendar. I'll tell you about other events that we're working on setting up. So where's this Google Calendar? There we go. Not month. There we go. I'm a little tired. I got like the worst sleep of my, this is one of the worst weeks for sleep that I've had in a while. It was brutal. So tomorrow, tag team debate on whether or not anti-theism is reasonable. Then maybe on Sunday, if I get a hold of Destiny on time, maybe a debate between Destiny and Pogan. Then Kent versus Maddie on Monday. That is still being confirmed, but I think it'll happen. We might have a new debate. And then I mentioned JF and socialism done left. That will be on Tuesday. That'll be a cool one, political one. And then another political one on Wednesday. It'll be between Mouthy Infidel and a new fellow. I forgot his name. I've got to find his name. But that should be it'll be a juicy one on whether or not there should be welfare. So controversial political one. Then Friday the 16th, Tom Jump versus Arjuna, who's a Hare Krishna fellow. I can't remember what they're debating. I think it's like, do we need God for ethics? Sphincter of Doom. Let's see. And that might be it. Sphincter of Doom and Balzac, General Balzac versus Cider and Leo might happen next Saturday. I've got to confirm that. Then Vegan Gains we might have on the 18th. Good old veganism debate. That would be cool. T-Jump we might have on not too long after that. We're going to ask Demon Mama, the YouTuber and Twitch streamer, if they'd be interested in debating T-Jump. And so that would be on whether or not deplatforming is good. So that could be epic. Rose and Alex may tag team on whether or not there are two sons. Serious. That should be a juicy one. And then, we've got, the Book of Daniel, Prophecy or Forgery. That's on the 23rd. We're going to try to get Sargon versus Mouthy Infidel on the 24th. No promises, but I am going to reach out to Sargon finally. And then also on the 24th, so we might have two debates in one day, would be Standing for Truth and Nephilim Free versus Amy and Randolph. That should be a cool one. Yeah, it's already been like kind of a hot minute since we've had Randolph. Heat Shield says Mars Helicopter Ingenuity first flight April 12th, 2:30 a.m. Eastern. Make plans to stay up late in 2 nights. Well, that sounds juicy. Thanks for letting me know about that. And Perfect One said, so when do we get Matt Dillahunty debating a flat earther? That would be epic. I don't know if he'd go for it. I can ask him, but I agree it would actually be cool. And Marka Ragnos, thanks for being with us in the chat. Recognized I like to lurk. Dr. Gildo says, say goodbye and get it uploaded. We're glad you're here. Master Optics, good to see you again. Stripper Liquor, glad to see you. Says, making me feel like a natural woman, James. I'm so glad to know that. Stripper Liquor, we all know Stripper Liquor is actually like Earl the Postman. He's like 65 years old from Alabama, but we love him. So, but yeah, we are excited, you guys. Let's see. General Balzac says, thanks for the heads up. That's right. Yeah, that's the hopeful date. That's when I'm hoping for it. So I've got to reach out to you guys. It doesn't have to be that date. We're open to different dates. Be Badass says, my Chromebook screen slightly glitchy. Should I just restart my computer? Hopefully a fluke. It's brand new. Yeah, I mean, I would try restarting it. If anything's, I don't know. I wish I was a computer person. I'm actually not very good at computers. John Smith says, have you considered either of the following debate topics? STEM versus STEAM, putting arts in STEM, and does the Abrahamic devil exist? Never heard of those or considered them, but I'm open depending on who is in the debate. So thanks for asking about that. That's interesting for sure. And then Top Hot 2 says, might have to be on your toes for Demon Mama. Yes, it could be a juicy, controversial one. We'll see how it goes. And Joker's Wild said, Sargon of Akkad, good luck with that, James. Well, we have had Sargon on like 3 or 4 times. So we had Sargon versus Brenton, Sargon versus Vosh, and I think we had him on one other time maybe. So yeah, we are like, it's possible. Frankly though, I think it is. I'm not sure. I don't know. I feel like I asked him once before, but I don't know if I did. I can't remember. But yes, we are excited, and so thanks everybody. Sigma says, I'm back for the last bit. Did I miss story time? We didn't tell any stories. I was just talking about future debates. So I should go though. I need to get some sleep. So thank you guys. Thanks for all your love and support. Seriously, you guys make this channel fun. You guys make it epic. Thanks for all your ideas. Thanks for all the support, like the likes and the shares and all just the grassroots stuff. Like that really does help. And so thank you guys so much for everything. I'm pumped about the future because of you. So thank you guys. And I hope that you really do have a great rest of your night. I love you guys. And General Balzac says, no, that's fine. Much more time than the 24 hours I had the last few times. I know you're busy as I have been. Next weekend works great for me. Thanks, General Balzac, for your willingness, your cooperativeness, and it'd be exciting and fun. So thank you guys for everything. I love you. Seriously, have a great night. We'll be back tomorrow night. It'll be a blast. Keep sifting out the reasonable from the unreasonable. And also, Deeds of Legend. Glad you made it. I see you there in the live chat, friend. And so, thanks for hanging out with us. It's always fun. Take care, folks.